So we are here for our very first lesson of coordination, and that is going to be coordination in animals. It's what we are beginning with. Yeah. Then maybe later on we shall cover that in plants. Yeah. So as usual, we always check the syllabus book where it's really necessary to check on what they really want us to cover as far as a certain section is concerned. So here it is, and you very well know the very first topic of senior 6. That is, of course, in term 1, it is coordination, and it is topic 6, according to the syllabus book. So, as far as section 1 competence is concerned, they talk about the role of plant hormones, of which we are not interested in plant coordination today. Yeah. So we are interested in animal coordination. And section 2 competence, that is it. And we shall read that statement when we reach the revision of scenarios in line with coordination in animals. So very first, I'll go to the first learning outcome, the expected learning outcome, which is the structure of the neuron, and you're required to identify the relationship between the parts of the neuron and, of course, the function, of course, using annotated illustrations. I think we are going to have a chance and also watch some videos of some of the neurons. Yeah, the sensory, the motor, the intermediate. We are going to do everything. Then part B, they are saying that watch a simulation of video clip on impulse transmission under varying stimulations. I think that will be next time. That cannot be today because the structure of a neuron is something big. Remember, we are supposed to introduce the topic and then we end in the structure of the neuron. Yeah, yeah, because you really need to know what really the topic is basically about. Then other things will come later. So trust me, concerning that video, it will be next time. Yeah, for today, I'll just introduce the next time. So that's where we are today. Yeah. So the lesson targets are going to be very clear. It's going to be the introduction to the topic. Because someone is like, the topic is coordination, then why is the first thing a neuron? Like, how are the two connected? You get the point? Someone is like, the topic is called coordination. But why is the first thing a neuron? How are the two connected? That should be the very first question. Leave alone these other things we've been studying. Yeah. Like, remember when I was introducing inheritance, but then I was starting with DNA. So we asked ourselves, how is inheritance connected to DNA? And we saw that. Leave alone topics like ecology, where introducing the topic, you begin with defining it, and then you go to an ecosystem, things that are related. So we are also supposed to know that why are we really starting with a neuron? Yet the topic is called coordination. So that's what I would say under introduction. Introduction to the topic. Yeah. Of course, you all know I never leave class without research and assignment. Yeah. So these are just the lesson targets. Yeah. Okay. So about the introduction, I'm going to first begin with something. I want to begin with something small. Um, if at all, if at all, um, if at all, you're moving somewhere. I don't want to use an example of a snake. Yes, I don't want to use an example of a snake because it is something that has never happened to so many of us. But I want to ask you, if at all you're moving in any direction, or you're moving from wherever, whether you're going from home to church, whether from home to a shop, and then out of the blue, the problem, some of us have been living in different environments. So what is that situation that can really be so common to us all? Let me just use the normal scenario in textbooks. You all know that if at all you touch a hot surface, you withdraw the hand. You get, maybe you try touching a candle, and maybe you feel some heat, you withdraw your hand. In case you get in touch with any hot surface that you didn't really expect, you always do that withdrawal. It's called the withdrawal reflex. But we shall reach those things of reflexes. I just didn't want to use technical terms. You get the point? But if at all the people who have lived in ghettos, even if you've never lived there, the moment you're backed at by a dog, in most of the cases you would want to run. Leave alone someone who has ever been trained and told that in case the dog barks, don't run. You get? But even if you're just moving somewhere and out of the blue you see people running, you also end up running. So there are a lot of things that happen and you can't really tell. As someone who is so innocent, you can't really tell like what's really happening. What's really happening here? Because you just touch the hot surface, you draw your hand. The dog just barks at you, instead run. You find people running, you also decide to run. But in case you first sit down and try to relate these things, they may not connect. Be like, why am I really doing this? You realize you're going to be doing a lot of activities in the same place. I don't know if you people are good at watching movies, but again, movies may not be a good example because not all of us watch. But the thing coordination, now I'm going to take it to English. Coordinating, if at all they tell you that this is the class coordinator, it's that person that coordinates different activities of the class. In case the class is missing the timetable, they look for it. In case the class has no sweeping rota, they make one. In case the teacher has delayed to come to class, they look for the teacher. In case the class has certain issues, concerns they want to raise and they need immediate address, it's the coordinator to do that. So coordination is all about the link between the different activities. But for this case, we are talking of animals. We are humans, we are animals because we belong to kingdom Animalia. You get? So the other thing I said first, it was a joke, though many of you didn't get it. When they say animals, it is still man because we belong to the same kingdom, Animalia. So you realize the eye sees the dog barks and the dog starts to run towards you, then you run. It's a few people who cannot run after the dog actually running towards them. Very few people. Yes, very few people. Maybe a northerner. But in case the dog barks at you and it immediately starts to run towards you, you're going to run for your life. But you just saw the dog actually barking at you and running towards you. You now started running. I don't know if you're seeing a link of body activities, like the eye saw, then you decided to run. Seeing, that is vision, and running are two different body activities. So there is a link between the two. You get the point? That's what they call coordination. I'm not going to write anything. I'm just telling you the story. When you touch a hot surface and you draw your hand, the other one was just a feeling, like you felt. Of course, you have you have those things that are responsible for feeling the heat. I won't say their name right now, but they are called receptors. But I don't want to mention a lot of technical terms in the introduction. But you have those things that are responsible for you, that are responsible for feeling the heat. And there is also you removing that hand, withdrawing it from the hot surface. Those are two different activities. I don't know if people get it. The activity of feeling the heat and this activity of you withdrawing your hand. So that means there is a link between those two body activities. That means there is someone coordinating them. There is a link. They are different, but they are linked. So coordination is all about different activities but linked together. Different class activities done by the same person. So there is a link. There is coordination. I've told you why you call that person a coordinator. It's because they do different activities of the class and they make sure everything is just sorted and they just link up everything, provided it's a class activity. So it's what we are also going to be looking at this side, but we are going to concentrate on the human body. How do different activities really connect? You get? Yeah. There are so many examples that I don't want to really use. Yeah. But you happen to realize so many body activities, they are totally different, but there is someone linking them together. You just run, running is different, but you end up sweating. Are you getting me? Running is different from sweating, but they are linked. Whoever is responsible for that is the coordinator of the body. And it's that coordinator of the body that we are going to look at today. Hope you've tried to get something. Yeah. Okay. The person who was called, thank you so much. I didn't know that I had muted. Sorry for that. but you missed some explanation, though not important. Maybe it will come back. Sorry. So coordination, I've been telling you, it's just like a link between body activities, and of course these body activities, we agree that they are different. Just understand it like that. And I've given you so many case scenarios about the different body activities that may be indirectly linked. You may not just see it obviously that they're actually linked, but they are. That's what we are going to look at today. Okay, now someone may ask, like, how do these things really come about? Let me tell you this. It is in most cases your brain that tells you what to do. So when for you just see a dog barking at you and then running towards you, it is your brain that tells you that now run. You get? But remember, things are coming from the eye. It is the eye that is really beginning all this. I want us to just use that case scenario of the dog. I don't want you to be like, for me, if a dog runs towards me, I may not actually run. But let me tell you, just assume you're just near a door, which door you can open and then close yourself. Can you really remain standing? Never. At least you try to run and get a position, maybe where the dog may not get you later on. So I'm teaching students, I'm not teaching the army. I don't want you to say that, for me, I stay. That means you're going to change the whole system. So just understand that the moment you see a dog, it backs at you and starts to run towards you, the next thing to do is to run. But remember, it is the eye that saw that. You get? The eye cannot communicate directly to the legs because it is the legs that are going to run, isn't it? So we have the eye there, or the eyes, and then the legs this side. So what you're supposed to learn is that the eye cannot communicate to the legs direct. How? How? All the eyes can do is to look at the legs. So they can never communicate. They can never communicate. Never, never, never. You first learn that. Yeah. They can never communicate. The only thing that when the eye sees the dog running towards itself, the brain gets a message, and then the brain tells the legs that now we need to start running. Then you start running. You get? So have it in mind. You all know it's your brain that does everything. So all the eye can do is to communicate to the brain. Then the brain can now communicate to the legs. Yeah. The brain can communicate to all body parts. Yeah. It is the main guy in the body. So have it in mind. The eye will watch. The brain will get the information, and then it will tell the legs that now we need to start running. So we are talking of a case scenario of a dog barking at us and then running towards us. Hope you are aware. So the case scenario in the building, it's a barking dog running towards. It's a barking dog running towards. Someone tell me, what name do we give to a person in an experiment in science? How is that person called? If I told you're dealing with an experiment, and that experiment is having a person in it, like this case, that barking dog is running towards the person, how do they call that person in science? That word is so common in biological science. What name do they give that person? It is only one person who is having the answer. It's called the subject. Someone is calling a subject a specimen. Okay, we are using a case scenario of a barking dog running towards the subject. Yeah, subject is now that person. You cannot say victim. Someone even said suspect. No wonder. Okay, now we are saying that the eye is what we'll have to see. But now the dog is barking and running towards me. Communicate to the brain will now initiate the running by making sure that the legs also get the message. So, there are a lot of things that are going to come just from what you guys are saying. Yeah, there are a lot of things that you're going to, a lot. So when you realize this, the brain is at the center. You get? Yes. We're having things this side, that is the eye, and then the legs this side. You understand? A. So the brain is at the center, then the other things are on the sides of the brain. So the brain is in the center trying to control everything. You need to take note of that. So this eye is the one that is going to receive. I think now I need to redraw. Yeah, I think I need to redraw it here so that people can get it. Let me first secure this. So this is coordination 1. Okay. So you're going to have our eye here. Yeah. Then I want to put the brain here like that. So brain is here so that we get all our biology from here. And you all know it is eye to brain. And then from the brain, you all know we shall have the leg. Yeah, you all know where that is all coming about. So we say that this eye I want you to listen. It's the one that will see the dog barking. Barking and running towards it. You know everything. Then we say that this eye will communicate to the brain. And then the brain will now be aware. And then this brain will also finally communicate to the leg. I want you to listen carefully. Listen. Okay. Now, the eye is seeing the dog first. So we say the eye is beginning this thing and then notifying the brain. And then the brain tries to notify the what? The legs. Prior to. Now, there are words that I don't really want to use because they are technical, but they are coming in later. But the good thing, you've heard of them before. You've heard of them before. Now, let me ask you something simple. If at all, you've been, I don't know, do I have someone here who has ever had a steam bath? Or someone who has ever moved to a sauna? Let me use what you guys have ever tried to experience, because I know you have ever moved at least from a bright room to a dark room or vice versa, eh? Or I can use temperatures. A hot room, cold room. Coordination is a topic which introduction needs technical terms to be met later. So it's a very hard topic to introduce. Okay, now you guys, when I move from a bright room, like brightly lit room, I'm talking of light. I'm talking of light. So we realize you're moving from a room that is brightly lit to one that is dimly lit. Then you're moving from a hot room to a cold room. So what we are realizing here, there is a change in our external environment. When you enter into a room, the room is now your external environment. As simple as that. Yeah, it's just like that. But it may not be necessarily that. It is possible that you you take ice after hot water. I don't know if you guys have tried that also, but it is possible. But I just want you to concentrate on this, these changes. Like you are taking ice, but a minute back you are taking hot water, or the reverse. I don't mind. Maybe you took ice first, and after ice, you're now taking hot water. Maybe you were in a brightly lit room, and then you're going into a dimly lit room, or you were in a hot room, and then you moved into a cold room. I don't know if some of you have visited banks. When you enter into a bank, especially if it has been during day, where outside it has been very hot, when you enter the bank, there are ACs, and ACs are a bit cold. Get the point? So you experience that change in your external environment. So I don't know, do you people know the name of that external environment? The change. I'm talking of the change. When you're moving from a hot environment and you enter into a bank, banks have ACs and they're a bit cold. You're stimulated. For you cannot feel that I've actually been stimulated, but that feeling you get when you notice a change that this thing is a bit cold. That's what they call being stimulated. So that change in the external environment is what they call a stimulus. Because trust me, when you take hot water first and then you immediately take ice, you will notice that change. So you're noticing that change because whatever is responsible for noticing it has been stimulated. You understand? So I don't know if people get me if I now say that that change is what they call stimulus because it has really stimulated you. That's why when you leave a dark room and then you go into a room with bright lights, that is a change. That's why you try to change the size of your pupil, but that's still in coordination. That's why I've told you it is very hard. Now I'm talking of changing size of your pupil, which is taught in sense organs, the very last part of coordination, the human eye. But you need to understand because they happen in daily life. There is a way you try to squeeze your eyes when you move from a dark room to a brightly lit room. So that change in external environment makes you to act. And still that is coordination because there are two activities that have actually been linked. So you just saw the bright light, and by the time you knew, your eyes were becoming a bit you get you're trying to reduce the size of your pupil, like you're trying to squeeze them. That's what I mean in a layman's language. So you learn what stimulus means, the change in the external environment. So when I talk of a room, this environment is external. You need to go away from those O-level definitions. So in O-level, they were telling you only external environment. But in O-level, we are going to what they call internal environment. Remember, you are taking ice, you're ingesting it into your body. So that environment, your body, your own body can't be external environment. It is internal. So you need to know about that also. You get? So why am I bringing all that? Why am I bringing all this? Because there is a term I want to introduce to you. And of course, that is stimulus. So that scenario and this scenario, the change in the external or internal environment, it is stimulus. So when you look at a dog that is barking and running towards you, for you've been in your peaceful environment, you people, they don't mind about the nature of the change. Yeah, you've been seated somewhere and you're peaceful. That is a different environment. Now when a dog starts to bark and running towards you, that's now a different environment. Yeah, you're now going to get a different message. The other time you had a peace of mind, you were sorted, but now the dog is distorting everything. That is a change in the environment you've been in, because it is actually biological, because it's going to incite fear into you. And fear is because of hormones, and hormones are biological. So you need to just understand the biology basically like that. So when you actually see the barking dog, I now want to change that statement to the eye receiving the stimulus. You get? That's all I wanted. Like the dog is receiving the what? The stimulus. But in the due course, I've defined what a stimulus is. Plural stimuli. You get the point? Now the question is, yes, we have accepted the eye has received the what? The stimulus. How is this stimulus going to reach the brain? That should be your question. Are you getting it? That is one thing that really disturbs people. How is this stimulus? How is this stimulus going to reach the brain? That is the question. This time around, I'm not going to write a lot. I'm going to say a lot and have very few funny sketches. Then later on, I will have to go to the notes, we read them, and we end the class. So how is this stimulus going to reach the brain? That should be your question. Yeah. When the president sends some people into a certain constituency, maybe a ghetto, or why they elect MPs in different constituencies, they want to know the challenges of these people. And then the MPs are supposed to put everything into writing and then send to the president. They don't record WhatsApp audio notes and maybe send them to the president's WhatsApp number if he takes it. They don't email the president, no. When the president sends people, they are supposed to understand what are the challenges of those people, whoever. Then they put everything into writing and then give the president. So you realize in most of the cases, how information is delivered is not how that information is actually sent to the person who is supposed to receive it. So even in biology, the same thing. You cannot just, don't think that the way the eye received the message is the same way the brain is going to receive it. No. The eye has its own ways. The eye has its own way it functions. So most people end up making a mistake and saying that the stimulus reaches the brain. It will never reach the brain. Never. That's why I'm wasting time to tell you all this. That you cannot say the ghetto people talk to the president if at all the president sent someone, or if at all there is a middleman. So it is the eye to receive everything. And then the eye should find a way of how this information will appropriately reach the brain. You get the point? And then this is it. This is it. This is it. Between the eye and the brain, of course, there should be a fiber. You guys know internet. Internet, without fibers, internet cannot move. You've studied ICT. You've heard of fibers. It is something that is so common. Without fibers, we may not have transmission of different information and data. So even in biology, the same thing is happening. That thing that is supposed to transfer that or transmit that information from the eye to the brain is what they call a fiber. You people, you need to understand this one. Because when the topic becomes hard in the future, we shall start talking about things like sympathetic fibers and parasympathetic fibers. So you need to understand what a fiber is. And after talking about the sympathetic ones, we shall have to talk about the preganglionic and then the postganglionic. But still, they will be called fibers. So you need to know what really a fiber is, so that you now go to the preganglionic and the postganglionic, so that now you understand what a ganglion is. And from there, remember, they are under one thing, sympathetic and parasympathetic. So you need to know, what does parasympathetic mean and what does parasympathetic means. Coordination becomes hard in the future when now they start joining words. And those words, they expect them to make sense. Yes, they'll be mixing everything up. So make sure you understand whichever basic I'm going to be talking about. So it is a fiber. It is a fiber. But this is it. This is it. You guys have heard of you've heard of cells giving us tissues giving us let me put it here. I don't know if I have some space here. I can just fix it here because I don't need to say much. You've heard of the cellular organization, eh? From the cell giving us tissues, the tissue giving us what they call the organ, the organ giving us the organ system, and then lastly getting the organism. But for me, I'm interested in those four: cell to tissue to organ system. Now, when they tell you that you need a fiber that is really going to transfer information from the eye to the brain, in the future we shall talk about the structure of that fiber, and it's what we are going to really see. So I was going to pose a question and ask, is this fiber a cell? Is it a tissue? Is it the organ? Is it a system? What is it exactly? But I think I'll bring that at the right time. Yeah, I'll bring that at the right time. I'll bring that at the right time. So the fiber, because where is it? Where is it? Okay, now just to take you back slightly, we say the coordination is the link between different body activities. And the system that really does this, because you're linking different body activities, you need different body organs. I want you to understand this, because we are talking of the eye, which is an organ. We are talking of the brain, which is an organ. You all know the eye is a body organ. Also, we are talking of legs. Of course, legs are body organs, though they are best called limbs in biology. But I was just explaining this like I'm explaining to a layman. So that means we are having different organs included in all this. And you know, organs come up with a system. So maybe the things responsible for the link, as I'm saying, or as you're seeing, they are organs. And organs need a system or come up with a system. So for this coordination to be successful, a system is needed. A system is needed for coordination. So that coordination is done by a system, is done by a system, is done by a system. I really wanted to tell you why it's really called the nervous system. I wanted to tell you why the digestive system is called the digestive system. I wanted to tell you why the reproductive system is called the reproductive system, because there are things that you'll find in your very first years at medical school. Yeah, but I don't know, I've just changed my mind because it is a long story. Why they call it the nervous system? Maybe people will ask the internet. I don't know if the internet has the right ideas. Yeah, But I'm going to just tell you, just learn it by heart. Yeah. So coordination, you're linking different body activities. That means different body organs are taking part. And organs make up a system. So that means for coordination to be successful, we need a system. All this coordination is done by a system. And that system in place is what they call the nervous system. Yeah, I'm not going to waste time and tell you why it's really called so. So have it in mind that it's the nervous system that is going to lead everything. Yeah, nervous system everywhere. So that's how the nervous system comes about. So, the fiber, I want you to listen. The fiber that is really going to help us to move information from the eye to the brain is what they call a nerve fiber. Because you now know the system in nervous system. So a nerve fiber. You get that? And this nerve fiber has another name, and that name is neuron. You get it? You'll find books that write it in some other way, but I'll tell you the plural form. So this the neuron in plural, I'll tell you the plural form. Yeah. But the plural form, they either put here ES or they just put S. But I'll tell you, I just need that space. So, someone may be like, yes, it's a nerve fiber, but does a nerve fiber really transmit the stimulus? Like the way the eye receives it, that is a no. It's a big no. It cannot transform the stimulus like the way the eye received it. So the nerve fibers only transmit what they call a nerve message. Transmit only nerve messages. Transmit only and only nerve messages. So someone may be like, what are these nerve messages? Yeah. So the nerve messages have a name. The nerve messages are the ones they call impulses in biology. Yeah. They're the ones they call impulses in biology. So that means when this eye receives the stimulus, this stimulus must be converted. Stimulus must be converted to what they call nerve impulses. Because the nerve fiber transmits nerve messages they call impulses. So must be converted to that. So this stimulus must be converted. Must be converted to what they call nerve impulses. And this process has a name. The process of converting this stimulus into nerve impulses. And you know, every time we transfer or convert things, they usually call it trans. You get in science. You know that transcription, you're converting DNA into mRNA. Translation, you're translating or converting the mRNA code into a chain of amino acids. You get? So even here we shall have the trans, but this time around we are dealing with impulses. So it's also trans, but this time around it's going to be called transduction. Transduction. Yeah. There are a lot of things you're really supposed to learn, and there are a lot of things I know in line with why certain words are called so in science. But I don't know why, for some reason, I feel like you guys will be overwhelmed and you will not actually get the examination points of view. Like I've told you why trans is trans. Now, I know a reason why it's added duction, why it completes as transduction. But I don't know, for some reason, I just think it may be irrelevant and I may end up going off topic, which I don't want. Yeah. So you find out why. But this is just a simple word to recall. You cannot forget it. Transduction. You also find it but I don't think you really still learn those things. Yeah. may not be so necessary. But the process is called transduction. The stimulus converting it to nerve impulses. So these nerve impulses can now what? Move. Yeah, they can now move in the nerve fibers from the eye to the brain. So we are calling them nerve impulses. Sorry. Yeah, nerve impulses. It's what I meant. Now, after the brain getting to know or receiving the nerve impulses, it's now supposed to communicate finally to the legs so that the running can now begin. Are you listening? Yeah. Now, what are you supposed to know? We are going to see that later. After the brain still getting to know that now we really need to run, it's supposed to communicate to the legs. But as I've told you, whatever is controlling this all is what they call the nervous system. And nervous system, it simply means a system of nerves, a system of neurons. You get the point? That means still this one is still a nerve fiber. Yeah, so don't think that the thing changes. Yeah, it's the nerve fiber still, because the brain receives nerve impulses and it will also transmit the same thing, nerve impulses to the legs, and then the running will begin. So we have nerve fibers there and here. Now, what is the other most important thing? What is the other most important thing? I think we shall do some other sketch. Let me just write the basic things. Now, this leg, remember, you've heard of things like responding to stimulus, responding. You've heard of those words, response and so on. People, I'm giving what they are calling an overview. We are going to begin reading our notes and you're going to see that most of the things are going to be clear and a few won't be talked about, and we shall also rectify them. So listen to the basics. When you read the notes, you understand them. We take screenshots, you go and read again, you make summaries, and that will be a done deal. So this leg does the final thing. Because the final thing is running, it does the final thing. That is the running. You get it? Yeah. And the final thing, I'll call it the effect. Like the effect of you seeing a barking dog is running. Are you following? Now I'm just going to say that and I'm not going to write it. But I'm like the effect of you seeing a running dog. Sorry. The effect of you seeing a barking dog running towards you is actually you also running for your life. So the final thing is running, like the effect. Okay? The effect of you touching a hot surface is you withdrawing the hand. You understand? So the effect. So because of that, this leg will get a name. This leg will get a name and it will now be called the effector. It will now be called the what? The effector. Because it is doing the effect. It is doing the final thing. And I've told you about the effect. So it will be called the effector. And if it's an organ, someone can really call it the effector organ. Or someone can even just say effector. It is enough. Just enough. Then, because you also need to learn this. Because it is the eye that received everything. I'm going to come here. You see, it is the eye that was doing the reception. The eye was receiving everything. The eye was receiving everything. We shall now call it the receptor. First, understand it locally. When you read the definition, it will make sense. Now you battle with memorizing. So because of the word receiving, it will be our receptor. Because of the leg doing the effect, the final thing, it will be called the effect. Now, for you're calling it the effect or the final thing, but that is local. That is local. Now the biology is supposed to be performing the response. But the only thing that can make you a good doctor, why I actually tell you all this, when you become a doctor, you're not supposed to use hard words. Yes, yeah, you're here to pass, but you train. You people, very many people get first-class degrees after becoming educators, but they turn out not to be good educators. Very many people graduate and become doctors, but they are not good doctors at the workplaces. What makes you understanding to patients and what makes you most outstanding at your workplace is you being in position to make your patients understand medicine, basically. So even when you progress, you need to always find ways of how you can simplify your work for your patients. Being in position to explain to a patient a concept that is hard and they really get it, but in their own way. So you need to learn these things. So effector, the real science is performing the response. Response, very important word in the subject. Yeah. Or you can just be doing the effect, but it is performing the response. You come across it. Then about the receptor, it's actually receiving the stimulus. And you know what a stimulus is? You get it? Yeah. Now, because this thing, this thing, this thing, we are talking of receiving stimulus. Receiving stimulus. Remember I told you when you take ice after hot water, your body inside, it senses that now we've had a change. Are you listening to the words I'm using? When you move from a hot room to a cold room, your skin senses. Are you listening to the word senses? So receiving stimulus, I'm going to change it with one word and say that sensing. By the mere fact you've sensed that you moved from a cold room to a hot room, you've received stimulus because of the change in the external environment, but you've sensed. So receiving stimulus is the same as actually what? Sensing. That's why in primary they used to tell us that the eye is a sense organ. Are you following? Sense organ. So you also come across the word sense what? Sense organ. Now, because it is the sense organ, now the eye is the sense organ. So I can now tell you that the sense organ, the eye, has what they call sensory receptors. Yes, it has receptors, but we can make it better and say that those receptors are sensory. So sensory coming from sense organ coming from sensing coming from receiving stimulus coming from noticing the change in the external environment. Now these fibers are moving from the sense organ to the brain. Are you listening? Are you listening? Hey, because it is coming from the sense organ, which sense organ has sensory receptors. So this sensory fiber or the neuron, it's also called the sensory one. You get? Sensory nerve fiber, sensory neuron. Are you following? Okay. Now, the brain, I told you before I go to the brain, this last nerve fiber is connecting to the brain. The brain is doing the final thing, and the final thing is running. People, most of the things we do involve motion, movement, or locomotion. You either move part of your part, you're moving part. You people, if I move part of my body without the whole body moving, is that locomotion or movement? When I just move my when I run, okay, let me use running. When I run, the whole body is moving. You get like I'm moving. Is that movement or locomotion? When you run, what are you doing? Are you moving or you're locomoting? Or both? It is both. It is both because locomoting, the whole body is moving. But realize as you're running, there are certain parts of the body that actually move. So it's both. But at your level, it's only locomoting. But you need to learn the facts. Learning facts at an early age is what really makes you a very good biologist. So that is good. So in most of the cases, motion. We don't want to learn. I don't know whether you have heard of motors. You know those motors that move continuously in that way? There are so many motors. There are those that move circularly. There are those that move radially. There are those that move in any direction. But why they are called motors, it's because of motion. That they are always, in most of the cases, they are in place. Motion is happening. You get the point? And since we are really going to our final effector, you know the effector organ, the one that does the effect. The nerve fiber that will be going there will now be called the motor. The motor nerve fiber. Because in most of the cases, it's going towards the effector organ that is going to perform motion. I'll tell you why really the motor is preferred. That's when we reach the autonomic nervous system. We shall just talk about it briefly. Though the syllabus didn't mention it like autonomic, but you need it. You need it. Hey, you need it because there are concepts you'll understand when you know it already. And how will you survive medical school without knowing the nervous system? Like how? It's everywhere in all course units. You cannot just leave the brain anywhere because you're talking of activities of the body that can never escape the brain. So this one is motor. You get? Hope we are together. Now, I remember telling you that the brain is at the center. Yeah, and I also put that one. Like the brain is at the center. Then I'm going to introduce more terms. It is at the center. The other things are just the other side. They're just the other side. So something new is also coming in, and I'm going to just put it here. I'm going to just put it here. So what am I saying? I'm saying that this brain is in the center here. Then this side, it's where I'm having the eye. Then this side, I'm having the leg. And we are moving like this. We are moving like this. I want you to follow. And I'm like, this brain is at the center. You get? Then you people told me that this is what they call the sensory nerve fiber. Yeah, the sensory nerve fiber. Then you guys have told me that this is what they call the motor nerve fiber. Hey. Motor nerve what? Motor nerve fiber. Then you guys added and told me that this eye will be acting as our receptor. And then this one will be acting as it's our effector in this case. And you told me this one performs the response, this one receives the stimulus. I don't want to repeat that. Now, this one is at the center. And the other thing that I really had to talk about but forgot. So the system of those nerve fibers, the system of those nerve fibers is what they call the nervous system. Yeah? Yeah. Nervous system. It is very clear. Even someone who doesn't know biology, if you tell them, what is the nervous system? What do you think what do you think it is a system of? They will tell you it is obvious. Because of nervous, they expect nerves. So it's a system of nerves, system of neurons, system of nerve fibers, you know those things. Okay. Now, I want you to listen carefully. 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 Okay. Now, this brain is in the center. And because of being at the center, it's going to get a name. I want you to listen. So this brain is in the center, as you can see, because there are things this side and also the other side. Are you following? So because of that, remember the brain also has fiber. Yeah, it's not that it's just there quiet. Yes, the brain is also having fibers, and remember it is just an organ, and organs make up a system, and the system in this place, it is the what? The nervous system, because it's the one that does the coordination. Are you people listening? The brain does most of the coordination, but remember the coordination is what? Is mediated, or is actually run by what they call the nervous system. And the brain is an organ that does the coordination. So it's like the brain is part of the nervous system. Are you listening? So it's part of, I'm going to come and say that the brain is part of the nervous system, which you guys understand. I've explained. It's part of the nervous what? System. But because according to our illustration, or according to all the biology, it's always in the center, because it receives and delivers, receives and delivers, receives from the receptor, delivers to the effector. So for it, it's always the middleman in the center. So because of that, I will tell you that it's part of what they call the central nervous system. The central nervous system. Why central? Because it's actually in the center. You people, the central nervous system is studied for 5 years at medical school. Yeah. Yes, I'll stress you. Someone may be like, you're also overtelling us about medical school. Can't you keep quiet? I can't, because yes, that's where I am. You also talk about your personal problems because it's what you have. You leave me to talk about my medical school in peace, because it's where you're coming. Every time I talk about it, you just need to say amen, 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 amen. So the brain is in the center, and it's part of now what they call the central nervous system, which you're going to start calling CNS. CNS. So from this, starting from today, CNS. You can even change your WhatsApp profile name to CNS. No one will recall. No one will get it. All your enemies will have to first go to ChatGPT to confirm what it really means. CNS. Now, I want to ask you something simple. If this is the cell and this is the nucleus, this is the nucleus, and then this is the cell membrane. Do you know what the Englishman says? The Englishman says that the nucleus is at the center, is at the center of the cell, because the whole thing is the cell. I understand you. Is at the center of the what? Of the cell. Or if at all I don't use the cell, I can be like, maybe this thing is the cytoplasm, you all know. Yeah. So someone still can say that that nucleus is at the center of the cytoplasm. But what if I tell you, rewrite the statement or the sentence beginning with cytoplasm? You people, what do you do? Let me even remove the cytoplasm, sorry, the cell membrane. I'm now talking about the nucleus N, this one, and the cytoplasm CP. So they tell you English question, that is all level. They tell you, number 43, the nucleus is at the center of the cytoplasm. Write the statement beginning cytoplasm. What do you say, huh? The cytoplasm is at the what? Of the what? I want to hear from you people. Let me tell you, back then, biology is a subject that you're supposed to read on your own and understand. You people have studied at an era where more teachers have graduated and schools have enough teachers. Of course, not all schools have enough teachers yet. You've studied at an era where technology is existing. That means you're in position to even come across such classes so that you benefit when you reach school. But those days, people used to pass biology without teachers, because biology is a subject that needs you to read on your own. I can decide to just make this summary. After the summary, I tell you to take screenshots. You go and read on your own. Because I will have cleared all the unfamiliar terms you may come across. You get that? Let me see what people are saying in the chat. The cytoplasm is surrounds the nucleus. Okay, what is the opposite of center, if I may ask? Let me see if people know some English. We say that the nucleus is at the center of the cytoplasm. So I also want you to tell me that the cytoplasm is at the dash of the nucleus. Now someone wants to say is at the surrounding. Someone is saying peripheral. Someone is saying edge. Peripheral. You people don't know English. It is called the periphery. Periphery. Hey. Peripheral goes with the central. Like the nucleus is central to the cytoplasm. Then there you can say that the cytoplasm is peripheral to the nucleus. But if I use center, like the nucleus is at the center of the cytoplasm, that means that the cytoplasm is at the periphery. And these words will come back in the eye when we talk about the retina and its photoreceptors. Yeah. So you need to know. Okay. So now the system of these nerve fibers, the ones that are surrounding the brain, as you guys are saying, because the brain is at the center of these sensory and motor nerve fibers, that means the sensory and motor nerve fibers are the periphery of the brain. They are the periphery of the central nervous system. That's why for them they are part of what they call the peripheral nervous system. So those two are part of what they call the peripheral nervous system. Yeah, it's the nerve fibers that dominate. Now, when we reach serious sessions where we shall go deeper into the nerve fibers, you realize that there are those that are spinal and those that are cranial. And there the biology will now be becoming serious. Yes, and trust me, you lose track. You lose track, you just end up giving up, you log off and wait for other things. Because now you will not be getting a thing. Yeah, which will be very bad. Yeah. So I talked of performing a response and everything. We talked of the transduction and everything. Okay. Listen. Okay. Now, I don't know if people are realizing that without nerve fibers, without nerve fibers, what? Without nerve fibers, so what? Nerve messages, or what we call nerve impulses. The other thing I forgot to tell you that these nerve messages electrical. That's why they call them electrical impulses. Yeah? I think you've heard of this before. So the nerve messages, what they call impulses, can't move. The nerve impulses or the nerve messages can't move. Can't be transmitted, and because of that, that means we cannot have coordination. And that means if we have no coordination, nerve system or the nervous system fails. The nerve system does what? fails. Get the point? Yeah. But remember these so the nerve system or the nervous system, because you don't have nerve fiber, that means even the structure is not complete. You get the point? And since the what? The nerve messages or the impulses can't be transmitted, it's like the nervous system cannot now perform its function. That means the nerve fibers are really a basic structure, like they are necessary structures in the system. So when you read any textbook and you find out that they are basic, why are they calling them basic? Because they are really necessary. Without them, nothing. And when we don't have them, that means the nervous system is not complete in terms of structure. Like the structure of nervous system is not complete. So it's the basic structure. And if we don't transmit the nerve impulses, like the system is not functioning. So it is basic structure and functional unit. And functional unit of the nervous system. Without it, the nervous system fails, as you realized. And it fails both in terms of structure and function. Yeah. Then the other thing you're not supposed to forget that nerve fibers, you know that in plural they are called neurons, like that. Or someone can fix in the ka-ie and say neurons. So they either end with S or ES. So when you find any, don't say that typing error. They are both okay and they are both there in your reference books. So you really need to know that. You really need to know that. So we are going to, I think immediately after talking about the central and peripheral, this is the point I really need to use to show you the divisions. Yeah, so that in the future you're not surprised, because this is supposed to be the introduction. So remember, animals, man, have vertebrates, because in BS they call it the vertebral or the vertebrate nervous system. They are vertebrates. You remember those things in primary science, vertebrates and invertebrates. The things I used to enjoy most back then in primary. Yeah, 2008. Vertebrates and invertebrates. Okay, now, if at all, you're having generally the nervous system of the vertebrates. So I would say the vertebrate nervous system. Yeah, I think that flow chart is even there in that book. It's having the central nervous system, we shall see the names, and also the peripheral nervous system. And I told you about that, isn't it? Then I remember telling you that the central has one of the parts as the brain. Didn't we say that? We talked of the brain, but we said the brain is just part. But you people know the brain never leaves the spinal cord, like they are best friends. So at your level and at all higher levels of education, you realize that the brain and spinal cord, they are the two basic parts of what they call the CNS, central nervous system. Then I told you about this peripheral nervous system, that for it, it's basically about those nerve fibers. And you saw why. It's basically the nerve fibers, Yeah, nerve fibers. So that's basic information that you need. Even when you progress, you just need to remember one thing. PNS, they are nerve fibers, sensory and motor. Then the rest of the coming information will just be flowing. Now, what I really want to tell you is that the story ends here for the central nervous system, the brain and spinal cord. Someone may be like, now, what of the other things we hear of sympathetic cue? How do they come about? So you listen carefully. Listen carefully. Remember these nerve fibers, these ones, they are the ones that take us to the effectors. The ones that perform the responses. They are the ones that do that final thing we really see. You run, you withdraw your hand, a lot of things happen. Now, I want to pose a question. In most of the things we really see, especially to do with motion, I'm going to use motion. There are things that happen involuntarily and there are things that happen voluntarily. Are you following me? A case in point, let me give you an example of blinking. Yeah, blinking has muscles that really push it. Maybe the blinking muscles, but you learn them when you reach certain parts. Yeah. Now, at medical school, you study what they call the anatomy of the head and neck. So as you're studying the anatomy of the head, you go organ per organ. So when you reach the eye, you look at its actions and you see the muscle response of everything. Because at your level, I don't even think you need the blinking reflex, but it is nice and very understandable. You people have reached A level and you realize there are things that are cheaper than some of the work you started at O level. So when you progress, you realize that there are things you will meet that will be cheaper than those you met earlier. So for example, blinking. Someone tell me, the English man or the English woman, is blinking done voluntarily or you do it involuntarily? And someone tell me what voluntarily really means. Because now these words are also used in science. The voluntary and involuntary. But you need to first tell me. Yeah. Which one do you do out of will? Like you decide to do it? The one that is voluntary or the one that is involuntary? You first tell me. You just tell me. You just write a full statement. You don't just say voluntarily or voluntary. You make a statement and say, willingly is voluntarily or willingly is involuntarily. Because at least all of us know that we don't blink willingly. We just don't know how it also happens. We just find ourselves blinking. You can force it, but in most of the cases, you can force blinking, but that's not the actual thing. The actual blinking happens without our consent. For us to force the blinking, it actually happens stubbornly. You just force it, but it happens on its own. So blinking is done unwillingly. You get? And by unwillingly, I want us to use the word automatically. You understand? Like it automatically happens. You cannot say something is automatic, yet it's you that pushes it to do that. So, blinking is done automatically. So what I want, of voluntarily and involuntarily, which one is automatic? Or which one happens automatically? That's what I want. I think people now know it. Yeah, so if people are saying that blinking is automatic and automatic is involuntary. That's what you people are saying, not so? That automatic is involuntary. Hey, yeah, you guys are right, you guys are right, you guys are right. You have content. So this balance is where we have those activities that are automatic and not automatic. So we have, when I say NS, I mean nervous system. Yeah? We have the involuntary nervous system and then the voluntary nervous system. I want you to listen. The involuntary nervous system is what they call the autonomic because of automatic, because everything happens automatically. So autonomic. So you learn why it is nomic, because from here I know. but I don't see it necessary at your level because I may end up telling you the meaning of everything. But auto, it is from automatically. If you want to find out why it is nomic, you learn. Then this voluntary one is what they call I don't know. You see, biology has a lot of things it's really connected to, but people just end up not appreciating. People just end up not appreciating. But I don't know if I should also bring this here. But anyway, people may be confused. Okay, autonomic, then the other one is somatic. Somatic nervous system. Or you can just use voluntary. It's okay. It's okay. Autonomic, then somatic. But that is just under PNS. Remember, the goal today is now this is what is ending the introduction. And then we shall now have to go and study the structure of what they call the neuron. Yeah. Okay. Now, I want to pose a question. You've gotten the involuntary and the voluntary part. Not so? And involuntary, you all know it is what? Autonomic, isn't it? And you have said opposite of autonomic in terms of nervous system, it will be the somatic one. These are all facts you just learned by heart. Yeah. Okay. Now I want to pose this question. You people studied what they call initiation of the heart rate and the control of the heart rate. Yeah. There is where you talk of the sympathetic nerve fibers, parasympathetic nerve fibers. They tell you those things. Vagus nerve and so on and so forth. They tell you those things. Someone tell me, the initiation of heart rate, does it happen automatically or it happens voluntarily? Do you even know when your heart rate is being initiated? Do you even know when it is being controlled in any way? Do you even know when the vagus nerve is actually taking part? So what do you think about that that thing of heart rate or heartbeat? Do you think the heartbeat happens out of your will or just happens automatically without even you knowing or without your own will? Some of you are not even aware that your hearts are beating right now, but you want to tell me in the chat that it happens voluntarily, yet you are not even aware that it's actually happening. So it's autonomic. You get? So people usually get confused when they reach here. And you all know that it is in those things of the heart where we talk about sympathetic and parasympathetic. So that's one way you can really recall it as a local biology student. You be like things of sympathetic and parasympathetic since I talk about them under the heart, and initiation of heart rate or whatever is automatic, so it's under autonomic nervous system. So the sympathetic nervous system, so it's actually called the sympathetic. Okay, at your level it is sympathetic nervous system, but there is one of the books of your level that calls it the sun. So when you find suns, I don't want you to be confused. Yeah. One time I asked a student, what is the sun? Then the student told me, sun, atrios manya node, what. So the suns, it is what? It is the sympathetic autonomic nervous system. Yeah. Like it is sympathetic. Why am I writing sympathesis? Yeah. Sympathesis is my favorite topic. Yeah, under CNS. Sorry for that. So it's sympathetic. Yeah? So why they call it the SANS? Because it is the sympathetic form of the autonomic nervous system. And then this side, I will have the parasympathetic nervous system. Or someone can come up and say the parasympathetic autonomic nervous system, the PANS. You get the PANS. I want someone who can unmute, who can raise up their hand and tell me those divisions. You raise up your hand right now. Don't delay. When you delay, you've copied. I want you to see that people are not copying notes. Okay, Judith, you tell us those divisions, then we tick introduction.
Good afternoon, everyone. Good afternoon, doctor. When we come from the nervous system, it's divided into the central nervous system and the peripheral nervous system. The central nervous system has the brain and the spinal cord, whereas the peripheral nervous system is divided into the autonomic or involuntary and somatic or voluntary. Further, in the autonomic, we have the sympathetic and the parasympathetic autonomic nervous system. Thank you.
Yeah, I think yeah, she has passed. She has passed it very well. That is it. So I think we are going to come here and tick introduction. I'm done with the introduction. So we are going to go and read something. Yeah. So I'm going to tick this. The structure is very easy because the key thing about the structure is actually the functions. Because even the syllabus book, you can see they just want us to relate the parts and function, period. So tewali nnyo mulimu gw'amaanyi. There is no serious task there. Okay. Where are we? So structure. But before we go to the structure, we're going to go about something about the introduction. We just read very fast. So what are they saying? Remember, it is coordination in plants that is supposed to come first, but for us, we talked of animals first. So they are saying, unlike plants, animals have two different but related. Yeah, they are different systems of coordination, but they are related. Nervous system, which I've told you about, and the endocrine. Now, this endocrine is the one that involves hormones. The one that involves what? Hormones. And the moment you talk about coordination that involves hormones, that one is called hormonal coordination. Very important at medical school. It's hormonal coordination. And really, hormonal coordination can only make sense or the comparison, because I'm seeing here comparison. Yeah, for this comparison to make sense is after you've talked about hormonal coordination. Okay, it's after you finish nervous. After nervous, you talk about hormonal. Then after hormonal, you come and relate. But to make matters worse, according to your syllabus book, they never specified so much about hormones, but you need them. Because after you talking about, this is section 2 competence, it's just about analyze impulse transmission in relation to the structure of a neuron, chemical synapse, and the factors that influence. That is nervous. You get. Then when you come section 3, examine the properties and functions of sensory receptors, the role of the retina, and then ear. So this is really the eye and ear only. Then 4, they wanted you to talk about behavior, like response and behavior. That's what they wanted. Like there is a way they try to escape. Hormones, which is not wise, but me, I'll teach them. Okay, I'll give you the course outline of what you're supposed to know, and you make your research. You just know these things, unless you just really want to pass and do business at campus. But if you want to become a medical doctor, yes, you learn these things from scratch, but this prior knowledge makes you enjoy medical school. Otherwise, you will struggle. I told you medical school, even if you're going to do nursing, even if it is public health, even if it is which, provided it's having the word health anywhere, or provided it's related to anything, even if it is a bachelor's degree in sanitation or personal hygiene, it is still health. You will study these things. That's how the colonialists designed our program of education, to keep us poor. So we have no option other than studying what the colonialists decided. Yeah. So I've told you hormonal coordination can only make sense. The comparison makes sense when you know about each. So I will not go through this. But maybe what you need to know is about the nervous coordination, because it's coordination by the nervous system. Yeah. So maybe I can only read through only these ones. They are saying involves electrical and chemical transmission of messages. We shall see the chemical part when we reach the synapse. But the electrical, I already told you that the nerve impulses are what? Are electrical. The chemical part, we shall see it. They are telling you it is rapid because we have realized you don't really understand how you immediately run when the dog just barks at you and it starts to run towards you. You also immediately run. So you realize everything is happening rapidly. Yeah, that's why they are telling you that the transmission is rapid, even the response is rapid because it involves the brain. Yeah, and the brain does things very fast. They are talking of often short-term changes because it is always very fast. So don't expect it to be long-term. In most of the cases, quick money gets lost so fast. Okay, in most of the cases, everything that comes so fast, you literally don't get it, or you literally don't benefit from it. Yeah. So they are saying the pathway is via nerves. That's why they are saying it is specific, that it is strictly by the nervous system. And nervous system, its basic and functional units are the nerves. Yeah. So they are saying the response is localized at one muscle. What they are saying that if at all you're supposed to run, they are going to concentrate on the muscles of the leg that are responsible for running. Yes, you study muscles at medical school and they will show you that triceps do this, biceps do this, extensor muscles do this, flexor muscles do this. You learn all those things. So if at all you really want to run, there are muscles that are supposed to flex, there are those that are supposed to extend. There are, or if that is hard, I can say there are those that are supposed to do what? To contract, there are those that are supposed to relax. You get it? So because of those different things, I think you understand. By when they say one muscle. Yeah. So if at all you're supposed to run, don't again expect them to trigger muscles of the neck. Something like that. They are saying messages originate from all over the body. Yeah, for us we have used the case scenario where the message is coming from the eye. But it can be the ear. It can be the ear. If at all you're doing practice, or if at all you're in these things of set, go on your marks, get ready, go. Those things. It is just the ear that is hearing that now go. So that is sound. When that sound reaches the brain now sets the legs into motion of actually running. Things like that. That is coordination. The body activity was hearing because it was sound, like set, go on your marks, get ready, go. That is sound. But then you end up running. Those are different body activities, hearing and actually setting yourself into motion. So there has been a coordination. But now the message is originating from the ear. The other time it was from the eye. So anyway of the body, provided you later connect to the brain. Hope you read those things and they make sense. About how you're supposed to memorize it is you. As an academy, we just need to make sure that whatever we read makes sense. If at all a point is not clear, you can tell me that, doctor, pardon on this point that says this. You just raise up your hand. The moment that statement makes sense, that's my role as a tutor. It is you to learn how to memorize your work. Yeah, school never teaches you memory because we have different memory and there is different ways how we memorize work. And we've been studying since baby class. You know how best you can memorize work, provided someone makes you understand it, and that is it. Behavior. And these are just notes. I don't know if it's really necessary. Let me see. Plants lack a nervous system but have a chemical coordination equivalent to hormones. Of course, don't expect plants to have nerves. How? It's even funny. but for them they have a system that is corresponding to hormones. Of course, we shall see that in what? In coordination in plants. You will see the gibberellins, you will see the cytokinins, you will see a lot of things that are related to hormones. You get? Yeah. Then these others, they are talking of control of the nervous system. Nothing much. So finally, they now introduce nervous coordination, which we are supposed to talk about. So the topic is coordination in animals, but even hormonal is part. Which hormone? I have not yet seen it anywhere, like in details in your book, but for me, I'll teach it. However, somewhere the book talked about hormones. So maybe that word alone, hormones, means that we should also look at hormonal coordination in details. But have it in mind, you need this information in the future. And NCDC is a different body from UNEB. This one designs the curriculum, this one sets the exams. So many years, every year, UNEB sets something that is not in the syllabus. You can check the paper of 2025, you can check chemistry paper 2. They said something about electrolysis, that is electrochemistry. They talked about, I think, determining standard electrode potential of the iodine electrode. Iodine is a nonmetal, and the standard electrode potential of nonmetals wasn't there in the syllabus book of 2013, but it was there in that of 2012 and below. And guess what? They said it. They said, so don't say that it's even if it's not there, they will say it, especially biology. These people will betray you, me, I'm sure. Because there are things you need and they were removed. I don't know why. And they are going to set for you questions with data analysis, making matters worse. So if you don't understand basics, you can't reason and you can't cram. Because they will always change the data. They always change the data. So it's the content that will really be your point of strength. Hope you understand. So nervous system, I told you it is a system of cells give you tissue, organ system. So it can be a system of cells, it can be a system of tissues, system of organs, system of cells, tissues, organs. That's why they put system of nerve cells and sensory organs. You all know these things. We said them. Sensory organs, it's like sense organ. And what do? They carry out coordination. And they do this by transfer of impulses. You know impulses. My role is not to make you cram this definition. It is you to cram. My role is to make sure you understand why it's a system, why nerve cells, why sensory organs, why coordination, why transfer of impulses. That is the role of a tutor. Yeah. Otherwise, if my role was to make you memorize, we could always just move from lesson to class. Sorry, lesson to exam. But there is that time of from lesson to the exam, that period of reading, mastering, understanding, and meditating, and so on. That's what that's what really counts. You get? So components of the nervous system. What are those things that really make part of the nervous system? Stimulus. They're saying this is the change in the internal or external environment. And I told you the internal and the external. I told you that. To which an organism responds, because we agree that the final thing is the response. It can be a change in heat, change in blood pH, change in level of a metabolite. We shall see that. The metabolite can be glucose. If at all your glucose levels increase beyond what you're used to, or what they call the norm, we shall see that in homeostasis. They also call the components of homeostatic system. They talk about the norm. The norm is called the set point. If you don't call it the set point, you can call it the reference point. So in case you notice a change in the level, or a change or a deviation from the set point, a deviation from the reference point, a deviation from the reference point, from the norm, that's what they call a stimulus. Okay, stimulus is triggered. Even now we talked about all that. Receptor, what is that receptor? Receptor could be cells, the ones I call receptor cells. It could be an organ. what we call the sense organ, or it could be any other structure that detects the stimulus energy and changes it into an electrical impulse. Didn't we say that? And we said the process is transduction. That when this eye receives the stimulus, it's having receptors that are going to exactly receive it. But it's not supposed to deliver it as it is. It must transduce it to a nerve impulse, electrical impulse, into electricity, so that it can be transmitted to the brain, where the brain is part of what they call the nervous system. You get that? Nervous system, very important. Hope that has made sense. If at all you read through also and you see any point that doesn't make sense, you raise up your hand and ask. Yeah, for us we say it's stimulus, but here they are saying stimulus energy. But anything in science must carry energy. Okay, central nervous system, the CNS, brain and spinal cord. They receive information from the receptors, didn't we see that? And they do the interpretation, because we know the brain is the control center. It's the one that does the interpretation. Next time they can call it the integration. So you should be okay with everything. The comprehension, integration, interpretation, processing, it's even here. Yeah, so they receive information from receptors, they interpret it, and then they command the effectors. That's why they call coordinating the response. Yeah? Like it's the effectors that perform the response, but it is this brain or the CNS that commands. So it's like they coordinate that response. And they process sensory information. Which information they get from what? From the receptors. I don't know if you guys try to understand that. Go. Effectors. Effectors, they can be muscles, they can be glands. I remember telling you about these glands. Yeah, I told you that if at all you're running and then you end up sweating, you're sweating because of sweat glands. Let us agree. Yeah, that is happening because of sweat glands. Isn't that true? Yeah, because of sweat glands. So the glands can also be. So sweating is the final thing. Yeah? It's the effect of running. So glands can be effectors. And here they are saying those are the parts of the body that carry out, or you can say that perform the response. And what is the response? The response is what you do. Yeah. It can either be part or the whole organism. I talked of movement and locomotion. So you can move, you can locomote. But don't say movement and locomotion. Just say change in the activity. Change in the activity. Because again, sweat glands producing sweat. Is it really motion? It's not. It's just an activity of production of sweat. So just say change in the activity. It's either part or the whole organism. And you're responding, of course, in reaction to the external change or internal change of the environment, either the external or internal environment. So, supposed to just make sure those words make sense. Then later you will read to do what? To master the work. So the functions of the nervous system, they are coming from the very sketch that we had. Yeah, the very sketch. Yeah, right away from receptors to effectors. How? What do receptors do? They receive the external internal stimulus. Then they convert it into electrical message or electrical impulse or nerve impulse, a process called transduction. So that's also a function. Then when they do that, they make sure it reaches the brain to be processed, interpreted, or integrated. You understand? Yeah. Then they say often in relation to past experience. Why they are saying this, we shall see this in behavior. That when the dog barks at you and you run for the first time, that means even for the rest of the coming times, you will just be running. That's why they are like often to the past experience. And the other thing, maybe a child sees a goat and maybe the goat is coming towards them and they decide to run. But later on, they realize that the goat actually has no problem. Maybe a young child. So when they realize the goat has no problem, the second time they may run, but they realize it has no problem, like it doesn't cause any harm to them. So that means in the future, the child will not run because the child has appreciated the fact that the goat has no problem. But we shall see that in behavior. Yeah. Where the response depends on whether there is actually a reward or a punishment. So the dog running after you expect a punishment, but the goat running after you don't expect any problem. So that's what they mean by often in relation to past experience. Yeah. Okay. Then after that, there is transmission to the effectors, and it's effectors that carry out the response. Things like that. So realize functions of the nervous system, we just use the other sketch. Receiving the stimulus, both internal and external, transducing it to the electrical impulse, reaching the CNS, that is the brain and spinal cord, where it's processed, interpreted, integrated. And we have said often or often in relation to past experience. And after that, it's supposed to be transmitted again to the effectors. And they are telling you they are specialized. Remember when we talked about them having the special muscle that will do what they want. So specialization is very key. Yeah. And then it's them that carry out the response. So they're just in line with whatever we've been saying. So divisions of the nervous system. Judith told us the vertebrate NS, it's having the central, it's having the peripheral, you get the point? And the central is having two things, that is the brain and spinal cord, and that's where it ends. The rest of the work is about now the peripheral. So the peripheral has the automatic part, the involuntary one, and the voluntary one, the somatic one. I told you these things are all having nerves, like nerve fibers. And I told you when we reach that content, that's where we shall talk about those nerves. That's why I didn't even bother telling you about this, that it's having nerves. You can see everywhere. I even told you that we shall see the spinal and cranial and see why they are called that. In future, not now. Okay, then I told you it's the automatic or the autonomic. You people, it is autonomic. Don't say automatic. Automatic is there to help you recall. And you can see it's having the parasympathetic, the sympathetic and parasympathetic, the suns and pans. You know what this means? You see? Obvious things. Okay. What do we have? What next? What next? What next? Now fibers. Now fibers. So I think enough fiber is the basic structure and function. Don't you know that? I taught. Hey, people, you see the things I teach here in the workbook? They are enough for me to end the class. But why I come back here is for us to read together. People, these are my notes, so I'm aware of whatever is there in most of the cases. I just forget a few things, and some of the things I leave them out intentionally with an aim of looking at them as we read here together. So when I finish the workbook, the lesson is actually done, but I just decided to elongate it so that we read together, so that when you're to read the same notes, you're reading things for the second time. So trust me, you will understand. That's why I tell you can take screenshots as I give you the time, convert them into a PDF, and then print the PDF and read the same thing. Or take the screenshot, read again from your phone, make a summary. A-level needs you to log in 24/7. That's why tasks are very hard. I wonder how you guys read with an error that has TikTok. That's why every student will get 20 points, starting from 2027. I'll respect those people. Because that control will require someone to be super motivated and really knows what they're actually doing. But there is a kind of students that is trying to phase out as the years proceed and proceed. There is a certain nature of students that is trying to phase out and phase out the nature we had. The nature or the kind of students we were, it's phasing out. I don't know why. Every year and every year, every year and every year, every year and every year, every year and every year. I don't know if it's going to be like that. Maybe that was the millennial generation and this is Generation Z. So they are saying that these nerve fibers are everywhere in the body and they form that what? Complex network called the nervous system. Yeah. Now they are talking of these things. They are saying that a neuron is what? Unipolar, bipolar, multipolar. Then they are saying that we are supposed to look at the histology of neurons. And here we are to look at the histology of the nervous tissue. Yeah, you know histology, they study tissues, yeah? Yeah. So this is where we are going to find today's work. And we are covering it right now. So I don't expect anyone to leave. So don't leave, you stay. We're going to cover everything right now. So I think we ticked the introduction. So the next thing is now the structure. Yeah. And the structure disturbs so many people. So many people. I don't know. You tell people to stop calling me. I don't know. I think I think everything is clear. Like you're seeing the screen, you're hearing me clearly. But I'm receiving calls from people who are actually in class right now. What's the problem? So structure of the neuron. So I can stop there even add E. But just don't be surprised when you find it. Yeah. Some of you are wiseacres. Yeah, whether you find it or you don't find it, for you, you're just supposed to treat it like the way it is. Someone tell me, what other name is given to a neuron? Like, what is that name? What other name can you give a neuron? And what do they do? I want someone to unmute. Tell me the other name and what they do. If you tell me those two, that means we can proceed because you now know what we are going to look at. Yes, I think it was 5.
Yes, good evening, everybody. Good evening, doctor. The other name for neuron is nerve, and their role is to transmit impulses.
That is not correct. That is correct in all level, not A level. That means you're
Transmit.
not listening. I want someone who has been listening. I told you the other name for that and even put it. So you cannot be giving me wrong things. Yes, Nicholas Owen.
Thank you, Doctor. Good afternoon, everyone. The name for the neuron is the nerve fiber and it's used to transduct for transduction.
That is wrong. That is wrong. You keep quiet. Another person. Yeah, that one has failed the role. You see, you're not following. Another person. Yes.
Good afternoon, doctor and everyone. Another name is the nerve fiber, and its role is to transmit nerve impulses.
Okay. Thank you for your trial. Okay, now, that is okay. Transmitting is okay. Though I wanted someone to tell me if the nerve fiber is sensory, it does this. If it is motor, it does this. But all of you are just disorganized. Okay, now we are going to ask ourselves. What are really the details? We just want to know the details of this line. For example, you all know that we have what we call the receptor organ, isn't it? Or what we call the sensory or the sense organ. You get? And then we are saying it's going to the CNS, isn't it? And you know the CNS. The CNS is the brain and spinal cord. So structure of the neuron, you all know that there are nerve fibers which are either sensory or motor. Yeah? So I'm beginning with the sensory one. Sensory neuron or the sensory nerve fiber. How can you be an A-level student and you say sensory nerve? What is a sensory nerve? What are you even saying? For me, I can only pardon your wrong answer if at all I have not said about it. But then you tell me that the nerve is responsible for transduction. You want to tell me transduction is the same as transmission? Very disorganized. So you all know that the sensory neuron is this. Yeah. So we just want the details of this line. Let me do this. Yeah, details of that line. Details of that line are required. Yeah, that's the requirement. Yeah, that's the requirement. Details of that line. It's all that we require here. You get it? Because you all know that's the sensory what? Sensory neuron. Sensory. So the details of that coloring, because you want the structure. I can even make it more clear and say detailed structure. Detailed structure. So if that structure is detailed, then we can really, okay, if we get the details of that coloring, the sensory neuron, that's what we want. Twagala kumanya, we really want to know. How is it connecting with the receptor organ? So we're interested one here. How is that line connected to the receptor organ? Then we also want to see here. You see? Like, how is that? How is that color line connected to the CNS? Are they just connected with super glue? Do they use gum? Like, what's there? And then that's we really want to know. What are the details here? Is it just like a thin line? Is it just a thin line? Or there's things there? So the things I want us to look at. And straight away we are going to begin. Yeah. So I think, I don't know, should we watch a video first? Or I first do the sketch? What should I do? Should I first give you the local sketches, then we watch the video? Because I've told you what you should concentrate on as you're looking at the structure of the sensory neuron. Like, how is it connecting to the receptor organ? How is it connecting to the CNS? And what are those things within? Like, that coloring is what I want us to really look at. You get the point? So what should I do? I want to see those people who think they graduated with me, those who are advising me. What should I do, my fellow graduates? Hey, you're calling my sketch a local sketch. Kale. Okay, now, this is the thing, this is the thing, this is the thing, this is the thing. Listen to the details. So this is the receptor organ. You people, I think you have ever been caned. You have ever been caned? You have ever been caned and you feel the pain. That means the bumps. It's the bumps that sense the pain. So I think I'm going to use illustration of the bumps. I don't know. I don't know which kind should I draw? But no, I may end up attacking some people. End up attacking some people. Let me just use a box and just be like receptor organ. But I believe you people could get it more if at all I had used maybe an example. Yeah, one of the forms of bumps. I mean, of course, buttocks is a body part, so I don't want anyone to say that I'm being vulgar or I need parental guidance in this. I don't. Bumps are part of the body. And the type I wanted to use are those bumps that have the first floor and second floor. So that we even have enough space to show how the nerve impulse is moving from the first floor of the bump to the second floor. But then I may attack the owners. So receptor organ, the receptor, sensory, call it the sense organ, like that. So we want to know what is the connection here? Is it just like this super glue? But that's not really the fact. So this is the thing, this is the thing, this is the thing. We have these things. We have these things, those ones. Seeing those things? These things are the ones that connect. Yeah. There are those that connect as 3 of them, connect as 2, connect as 1, like that. Are you seeing that? They are the ones that help us touch the receptor organ. Are you seeing that? Then after that, we are now going to have this. I think okay, let me remove this. So after that, I want you to listen. So these ones, is the receptor, so it's the one that receives, that picks the stimulus. Or someone can say receives whatever. So if at all this one is going to be our sensory neuron or the fiber, I want you to listen carefully. This is our sensory neuron. How is it going to receive that stimulus? In whatever way. So remember, transaction takes place and so on and so forth. So even the nerve impulse, it's like also coming like the stimulus. So don't mind when I say receiving the stimulus. So it's like they receive the stimulus as maybe nerve impulses, no problem. But the question is, how are they called? So these things you're seeing, those ones, there are many. They are the ones they call dendrites. Yeah, they are called dendrites. Why they are called dendrites? It's because they receive the stimulus. Yeah, dendrites. They are the ones that receive the what? The stimulus. Remember, so that means we are moving in this direction. Yeah? That's the direction. That's the direction. You need to be knowing that. That's the direction of nerve transmission, or the direction of the nerve impulse. I want you to follow very well. Very well. Now, remember, we are talking of a nerve fiber. We are talking of a neuron. You get? These things should have cells, at least. Because we are talking of a fiber, just a fiber. It is very difficult for something to have activity. Remember, we are talking of the body. The body needs what they call cells. Cells are the ones that control body activities. But remember, even cells have, you listen to this. The body has body activities, but the body has cells. But even cells have what they call cellular activities. So any body activity is a combination of cellular activities. But remember, cellular activities are controlled by the nucleus. That means without the nucleus, we cannot have cellular activities, and without cellular activities, we can't have body activities. Get the point? So, cells are always very important in this. So, as far as the sensory neuron is concerned, as the impulse is being transmitted, as the impulse is being transmitted, guess what? We meet the cell body somewhere here. Let's remove this. Yeah, we meet the cell body like that. And then everything continues. That is very important. As the thing is being transmitted, I've said, what do we come across? I think that is better. Come across the cell body. That is what they call the cell body, and then everything continues. But you should be knowing, where are we going? You all know that we are going to the CNS. So this one is going to continue like that. So when it reaches these ends, the same thing happens, the same thing happens, the same thing happens, the same thing happens, the same things go off. But this time around, they are a bit different. Yeah, you're going to have things that are going off. So they also go off like 2, you get? It can go off as 1, it can go off as 3, you get? But it is like that, like dotted at the end, like that. Dotted at the end, dotted at the end, dotted at the end. Like that. You see that? So where are these ones touching? These ones are now touching the CNS, you get? They are touching the CNS, they are touching the CNS, they are touching the CNS, you all know. That's what the sensory thing does. Yeah, they are touching the CNS, they are touching the CNS, isn't it? And of course, after passing that, after passing the cell body, it's like the thing continues, the impulse proceeds to be transmitted. I want you to follow this structure well, so that when you watch the video, you're not confused at all. Okay, now, what else? What are those additional things that we may be having? Yeah, now this neuron is insulated. insulated. I think you guys have heard of insulation. Yeah? If this is the skin and you have fat deposits, like deposits of fat, that's why they call insulation. You all know that your skin has hairs, and they tell you that those hairs are as well what? Insulated. Sorry, they insulate the skin, sorry. Hope you guys now get the what? The thing of insulated. So this neuron is also insulated, and we are going to put those cells in. So those cells that insulate it are like this. I'm going to draw them like that. Do you see? Then they can also draw them like that, depending on what someone wants, provided they show the kind of cells. They can draw them like that, whatever they want. So remember, this one was our cell body, so we expect it to have a nucleus. So I will draw the nucleus here, like that. Then also these ones that I've just drawn, I've said they are cells. So I also expect them to have the nucleus, each of them. So I'm also going to show it. Yeah, just put one dot in. Show the nucleus so that someone understand that, oh, these ones are cells. So they are the same, just because I've used different designs on top and down. That, like that. Yeah. Then the other thing you need to understand that the cell body around its nucleus, it's having some things. You know, we expect it to be having the cytoplasm, but instead, for it, it's going to be having some weird, yes, it may be having the liquid part, but what dominates are those granules, the Nezo's granules. In case you have any problem with pronouncing any word in biology, you go to the internet and check. You never waste your time, just go to the internet and check. Just say the pronunciation of this word and they will bring it. So you people, that is all. That is all about the structure. Provided you guys understand that this arrow is showing the direction of nerve impulse, because it is supposed to be from receptor organ to the CNS. Direction of nerve impulse. Direction of nerve impulse. If you can understand that, then the rest of the things are going to be very easy. So what are these things that we actually seeing? We can start on the labeling slowly. Okay, now I want you to listen. This one is our cell body. This one. Cell body. Are you listening? Then this thing in black. Oh, I'm going to show two of them. I can even add on the third, but they are called Nezo's granules. Like this is the Nezo. Niss, like that. Nezo's, that's what I prefer. Provided you don't put P, but Nezo is like that. So Nezo's granules. The person was called Nezo. So they are called Nezo's granules. So this thing in the middle, that one is just the nucleus. I think I should remove this because I may need that. So that one is the nucleus. So that is the cell body. Now guess what? I want you to look at this thing, yeah? Be careful here. I want you to look at this thing. Are you seeing this? the one that transmits from the receptor organ to the cell body. Then there's also this one, the one that transmits from the cell body finally to the CNS. The two things that usually disturb people are basically axon and dendrites. So you need to know dendrites are just receiving the stimulus, as we said. But remember also dendrites have what they call when they join together, or to make it best for you and understood, when these dendrites join together, that immediate thing they deliver to is what they call the dendron. Is what they call the what? The dendron. You understand? So it's also having the R of receiving. So it's like it receives from dendrites. So when dendrites get together, they give us what we call the dendron. You get? And then I'm here to tell you about the dendron. That for it, let me just extend it somewhere here because I need some good space. So it's the dendron for reasons I've given. So for it, it is connecting from the receptor or sensory organ up to the cell body. That's where the dendron stops. I want you to listen carefully. Yeah? Then when the impulse reaches the cell body, it now proceeds to the CNS. Yeah. So the sender, the one that sends now impulses from the cell body to the CNS is the axon. Yeah. It's what they call the axon. Yeah. So that axon is our sender. Then dendrites, because of that R, it's the receiver, and when they join together, you get the dendron up to the cell body. Then the sender to the CNS, like sending finally to the CNS, it is the axon. That's what they call the axon. So you need to be knowing those things. You need to be knowing those things. Now, there is something funny. There is something funny about this. What are these things that are doing the insulating? Remember, insulating is in most of the cases done by fat. Are you listening? So I want you to assume that what you're seeing here is fat. Just because some of you don't want to read the textbooks. But if I may ask, is there anyone who has ever studied coordination here? Is there anyone who has ever studied coordination here? I don't know. So no one is raising up their hand. But what you need to understand, that this thing you're seeing, the one that is doing the insulation, that one. So there are two. I'm going to use the one from this cell and also from this cell like that. So what you're seeing there is what they call the myelin sheath. Myelin sheath is a lipid. I can say it is a fat. So it is doing the insulation. Yeah? So it is a lipid, it is a fat. It is doing the insulation. So it's called the myelin sheath. Someone may be like, but you told us it is insulating, and all we know it is fat that insulates. Yes, this thing is a fat. It is a fat. It is a fat, or call it a lipid. Yes, I was right, and you are also right to remind me. So myelin sheath. Are you following? This thing you're seeing, that one is the nucleus. I even warned you already. Is the what? The nucleus. Then that membrane. I want you guys to go to the internet right now. Internet, you go there right now. I don't know if it will provide the right biology because people don't read textbooks. I would just tell you to go to Michael Kent because it brought it out very well. You ask the internet, what does lemma mean in biology? Lemma, like this, lemma. What does it mean in biology? Lemma. What does it mean in biology? You tell me. Go to the internet, and tell me what lemma means. Lemma. Anyway, lemma simply means membrane. Yeah, lemma simply means membrane. That's why in cytology I usually tell students that what they call the cell membrane is the plasma lemma. Yeah, plasma meaning membrane. Sorry, lemma meaning membrane. Plasma lemma. So that membrane of the sheath, it's also going to get a name. Yeah, because it is covered, that membrane is covering the neuron. Eh? It's covering the neuron. Neuron. So we want to add the membrane of the neuron. So we want to join these two, neuron and then lemma, because lemma means membrane. We want to join the two. So the English people decided to remove this and put I. And then say neurolemma, neurolemma. That's the membrane. You understand? That is the membrane that is trying to cover the neuron, as you can see. You just look at where I'm putting neurolemma. I think you can see that it is the membrane trying to cover our neuron. Neurolemma. Just like plasm, yeah? We have what we call the cytoplasm for the cell. In this topic, we shall see the exoplasm for the axon, and it is also there inside the axon, the exoplasm. You know what they call the nucleoplasm inside the nucleus. You see, so many things. Just need to be flexible as far as those terminologies are concerned. So realize we have something in common. We have we have the myelin sheath. It is together with the nucleus and also together with the neurolemma. So those three things have a general name. Like when you get the myelin sheath, you get its nucleus, you add on the neurolemma, you come up with a complete cell. Yeah, and that complete cell is what they call the Schwann cell. Schwann cell. Yeah. Double N, capital S, because Schwann was a person. Yeah. Most of the students during our era couldn't understand Schwann cell and the myelin sheath. But that is it. Yeah. And someone may be like, and to make matters worse, it is this Schwann cell that actually produces the myelin sheath. But again, the myelin sheath. So the myelin sheath is part of the Schwann cell. Produces or secretes the myelin sheath. I think you people can see, yeah, that the combination is a cell. Like you have the sheath, you have the nucleus, like this is the sheath, yeah, around the nucleus. Then the membrane enclosing everything. You can see now it's a complete cell with the neurolemma, the nucleus, and then the surrounding sheath, the myelin sheath, making up a complete cell, the Schwann cell. Schwann. I don't know if you can listen to Google. Let me get my Google here. We get the pronunciation of Schwann. Actually, we can just use something here. Let me see. Let me see. Let me choose this. No, let me choose this. It's better. I show you something about the pronunciation of Schwann. And trust me, we are done. Because when we finish up the structure of the sensory neuron, the one of the motor neuron is nothing. They're actually the same. Then I tell you the secret behind the relay neuron and we are done. Yeah. Okay, so let me hope people can see my screen. Yeah. I think this was the other time when we are watching the mathematics. So we are going to ask, what are we asking? Pronunciation of Schwann. How do you just put everything in the internet? Everything is there. Pronunciation of, before I even complete it, I know they will bring it. You see? They're already there. Pronunciation of Schleiden and Schwann. Schwann. Maybe let's take both. The videos are always there. You see how to pronounce Schleiden and Schwann correctly, and they are putting cell theory. So these things are under cells, and it is just 53 seconds. Can you fail to do that? Okay, let's see.
We are universally accepted that living organisms are made up of cells that are the basic structural unit of all organisms. How do you go about pronouncing those two German names? Schleiden, Schleiden, and Schwann. Schleiden and Schwann. Schleiden and Schwann. Here are more videos on how to pronounce the names of famous German people from history, including many German scientists. That living organisms are made up of cells that are the basic structural unit of all organisms. How do you go about pronouncing those two German names? Schleiden, Schleiden, and Schwann. Schleiden and Schwann. Schleiden and Schwann. Here are more videos on how to pronounce the names of famous German people from history, including many German scientists.
Have you heard?
All of those names that you may want to hear and nail them.
Have you heard? Schleiden, Schleiden, and Schwann. Because I know some of you wanted to argue. But I think you realize that I'm actually not your mate. Yes. Schwann. Schwann cell. What else? What else? What else? What else? What else? Yeah. Schwann cell. We have the archizone. I've talked of the archizoplasm. They are the same things that we are going to come across in the motor one. And trust me, I'm not going to draw a lot of them. I'll just show you how different they are. You get the point? Yeah. If I look at my structure, I'm only remaining with maybe telling you about that space. You can see that between those cells are the ones that are insulating. Yeah, we have some space. And you guys know, you know what they call, you know a sugar cane? You know a sugar cane? Or maize, whatever. They have these things. And you all know, this one is called the node. Then this one is called the internode. The people of physics, you know stationary waves. You know the illustration of a stationary wave. You all know that. That this one is what they call the node. Here, where we have maximum displacement, the antinode. Node again. So this region is the internode. You get the point? You know those things. So, even here we are going to have the same thing. Yeah. We're also going to have that node, that region. It's going to be a node. Though there is a person who gave it a name or someone who identified it. So that person decided to name it in respect to their name. And that person was called Ranvier. Ranvier. Yeah. About pronunciation, you can use YouTube if you want. You can use Google. Yeah, even Google can help you pronounce. Okay, now, the node I'm talking about, I'm talking of this space. I don't know, maybe I should use blue. Are you seeing this one? Are you seeing that space? Check where that blue line is coming from. That space, that one, that one, that one. Yeah, that one is our node in biology. And it was someone's node, and that person was called Ranvier. So as you're writing the node of Ranvier, this R should be capital. Node of Ranvier, like there in the middle. Should come from. That is better. Node of Ranvier. So everywhere between them, node of Ranvier, node of Ranvier. So that is the structure of the sensory neuron. You look at it. Before maybe we can even watch the video about it. And I want us to watch the videos at once, even those of the motor. Because concerning the motor, there is actually nothing much. There is nothing much. There is nothing much. So now the motor, I know it's from the what? It's from the CNS and then to the effector. So we need to know how things actually happen. But you just need to know the difference in the structures. That's what they want. So I just believe that is very clear. So before I talk about the node of Ranvier and everything, let me just show you something about the motor. Yeah, you don't want to waste a lot of time on it, because now what you guys need are the functions of each of everything that we've looked at. So you all know it's going to be the CNS here. You get? Yeah, it's like our sensory now delivered already. Now the motor. That is the CNS. So you all know the sensory neuron has already delivered. So now we expect the motor to help us take everything to the effector. So this side, we are having our effector waiting. Effector organ. Now we are going to look at how does it really move. Remember, we expect a lot. So remember, for the sensory, somewhere we came across the what? The cell body. But to make matters worse, this time round, things are different. Things are different. Things are different. Yes, we are having those dendrites. Yes, the dendrites are there. But this time round, we have something shorter. Just a moment here. Just a moment. So I said that this one is going to be our motor neuron, the one we are handling next. And I said that here we are having our CNS. This is where we have the node of Ranvier. Ranvier is supposed to be capital R to respect the person who named it. Okay, so here we are having our CNS. Remember now the sensory delivered. Yeah. sensory neuron delivered. And now we want to see how the effector organ is going to get information, of course, from the motor neuron. So this is our effector organ. So how is it really going to move? So I was saying that, yes, I believe we are having the dendrites as usual, as we expect. Yes, they are there. But now the question is, how are they going to be aligned this time round? So yes, they are there. They are there. But this time round, it's a bit different. Yes, this time round, it's a bit different. You see, we are going to have something like that. Someone may ask, what's really that? Maybe I'm even drawing something so big. Yeah, I think that will work. Something like that. So this time round, this is our cell body. Yeah. So it's bad news. We have something different. So this time around, our cell body is very near. Yeah, that's the cell body. So these dendrites are actually connecting to the cell body immediately, in any way. So when I'm connecting them like this, whatever, anything. So those things you're seeing are the dendrites. So this one is our cell body because it's even having what we call the nucleus. You get? And then you all know that the cell body just around the nucleus, it has those dots. And you all know what those dots are. The Nizos granules, and I'll tell you what they do. Yeah, those ones, those granules. And I won't label them again. Yeah, those granules. Then you know that these ones are the dendrites. I can tell you. Those granules. Do you see that? So this time around, you may have the dendron. It may exist, but you may not see it very well. Yeah. Like, for example, someone can tell you that this carrion here, this one in red, someone can tell you that this carrion is a dendron because they are getting those two dendrites I've tried to label, and they are coming together, and maybe they are joining the same place. But that one shouldn't be the concern. What you should concentrate on is that the dendrites are immediately giving us the cell body. Not like in sensory where you're supposed to first move like that. We together. So we have the nucleus there, and that is our cell body. So after here, we are now going to have the continuation. So this one is going to be straight. Without wasting time. Straight. Like that. Without wasting time. Then maybe when we reach here, anything can happen. The knobs can actually start going off, or you can first have such a division, very important. You see everything in different books. And then after here, we can have our knobs. And then they touch the organ, the effector organ. You guys know what to do. Things like this. Things like that. Yeah. But you all know they first come together like up to this point. That's where they come from. Yeah? I know some of you will become teachers. So I'm teaching you how we illustrate. First bring them together like this. Then here like that. So when they come together there, now you start. You get off your knobs. You get. Then here, bring them together. Then you start, you bring off the knobs, you bring off the knobs, bring off the knobs like that. Yeah. So I don't know. Here we didn't label those knobs, but let me tell you, you all know, all of you are know English. So I believe you are aware that these things are called knobs, like these ones. Why do I even circle them? Those are things you all know, they are called knobs. But which knobs? Synaptic knobs. I'm going to tell you what they call a synapse. Someone may be like, but why are they really called synaptic knobs? Yeah, those ones are they called synaptic knobs. Yeah, synaptic knobs. Okay, so this is it. The moment you're having here your receptor organ, receptor sensory organ, and you're having your CNS here, and then you're having your effector here. What I really want you to understand that those connections, are you seeing those connections? Where you have synapses there. Yeah, where you have synapses there, especially here. Where you have the synapse. So I'll tell you what a synapse is. It's like a connection, even here. Find the synapse. So that's why we are calling the knobs there. That's why we are calling them synaptic knobs. Yeah. You also learn that the synapse plays a very important role in nervous transmission. Then we'll understand it more. But just have that in mind, that every time you're having that connection, you understand? Every time you're having that thing, the synapse must come in. You know, if you guys are getting me. Like, for example, this is a fiber. Any fiber, I'm not mentioning whether sensory or motor. So this is a fiber. And then you find out that this fiber now wants to enter the CNS. Maybe that is the sensory. And then you also find out that this fiber maybe now wants to enter the effector organ. Those are the things that they usually enter. Effector organ. So the other thing I want you to understand as a biology student of A level, that this synapse thing is all about entering. It's all about entering. So this fiber, if it is sensory, then we expect it to enter the CNS. So as it is entering the CNS, that part is what they call a what? A synapse. Then if the fiber is entering what we call an effector organ, that means that fiber is what? Motor. And at this point where it is entering, we expect the what? Synapse. So that's another technical term. You learn it today. So trust me, when we define a synapse, we'll understand, because it's one of the things that we shall cover, I think in lesson 3. Yeah, lesson 3, I think, we shall cover about the transmission across a synapse. But you need to know what is that synapse, where is it located. So it's all about entering, the fiber entering the CNS, the sensory, the effector organ, the motor. The things you need to be knowing. So we are together there. So what is the other thing you need to understand? We need to understand that we still also have the insulation. So the direction of impulse is this one, because we are moving from the CNS to the effector organ. So I think people realize that the direction is not confusing you, because it usually confuses if at all you didn't have a good introduction. But now you people know the eye, the brain, and the leg. So you can easily get CNS to effector organ, that is brain to leg, and you know that neuron is motor. You understand? So we still have the other things. So here we don't have any cell that is interrupting us. So people know that the thing I've drawn is the neurilema. That is the nucleus. And then around the nucleus, we have the myelin sheath. And the combination of myelin sheath, the nucleus, and the neurilema gives us what we call the Schwann cell. And then these spaces are the ones they call the nodes of what? The nodes of Ranvier. Yeah, isn't it? Is that really hard? And you all know the dendrites, they do the receiving. The other thing I've not talked about is the Nisos granules, and I'm also going to talk about them. Yeah, Nisos granules. Most of the things I'm going to just mention, then we shall later read the notes so that you people confirm that what we said was actually okay and we're on the right track. So you people realize that we are only having the sender, and our sender is the axon, because we are moving from the cell body to our target organ, the effector. So we are just having one sender, and that is the axon. I told you those who may need the dendron may be somewhere here, but you may only see it microscopically, where you can see two dendrites that are immediately joining the cell body at the same position. But we just need to understand that sketch, local sketch. Trust me, when you watch the video, everything will be making sense. So I think the next thing is to talk about the role. But before I talk about the role, I want you guys to first tell me if at all the local structures are okay. I talk about the roles, we watch the video, we go through the notes, and then we leave this place. Yeah. I don't know if it is okay. I don't know if that is okay. Are the sketches okay? Are the sketches okay? Okay, if at all you have a question, you just raise up your hand. But I think no one is having questions. So I just want to talk about each of them very fast. We watch the videos. We are not going to watch many because these ones are actually better. The sketches are better, then you just need to read notes. So I'm going to talk about the different things. So I'm going to do that. So we have what we call the cell body. The cell body, of course, has a nucleus, isn't it? And the nucleus controls cell activities. So the other thing the cell body is having are the Nisos granules, and I've not talked about them. And they were so common in the old curriculum. In the old curriculum, such things like Nisos granules, they used to attract the attention of people who set multiple choice questions, the objectives. Yeah. So have it in mind, Nisos granules are all about, okay, let me ask you people, which cell organelles do those Nisos granules resemble? If at all someone asks you that, what do they resemble? Yeah, you just look at the structures we have been drawing, and someone really asks you that, what do those Nisos granules resemble in the cell that you know of? Ribosomes. Why are you people saying ribosomes? Okay, let me ask. You first wait. I may be teaching things that you people already know. You're right. And actually, what? And actually, you're right. Okay, Nisos granules are groups of ribosomes, but so many of you are saying ribosomes and so on. Do you know it already or you don't know? I'm only asking those who have responded ribosomes, because Nisos granules are actually groups of ribosomes. So those people who have been saying ribosomes, have you been knowing this or you don't know? Do you know it or you don't know? So you either tell me you know or you don't. Do you know that Nisos granules are groups of ribosomes, or you don't know, you just say? They just resemble, but it doesn't really mean that you know. Hey. Okay. Because I may be wasting time for people who have content. So these are groups of ribosomes. Who knows the role of ribosomes? Okay. You people, where else are ribosomes found apart from the cytoplasm? Where else do we find ribosomes apart from cytoplasm? On the rough endoplasmic reticulum. So that means the Nezo's granules are groups of ribosomes and also the rough ER. Yeah. You get? And these ones, you know, they are very key in protein synthesis. Protein synthesis, this one I taught. So those who are asking themselves how ribosomes contribute to protein synthesis, you visit the lesson. So those are Nezo's granules. Yeah, Nezo's granules. They are groups of ribosomes and rough ER, and they're responsible for protein synthesis. You tell me, who modifies proteins? Who modifies proteins? Who modifies proteins in the cell? Who modifies proteins? Because you know they need modification. Eh? Maybe you get what they call the lipoproteins, glycoproteins. Who modifies proteins in the cell? The Golgi apparatus. Yeah. People, you have content. So the Nezo's granules may have the Golgi apparatus. They may have the Golgi apparatus because the manufactured proteins may need some slight modification. Yeah, that's about Nezo's granules. You need to be knowing that. If you know the dendron, dendrites, and so on, I don't want to overstretch myself on that, but have it in mind if people, art is not easy. I think that will work. It will be okay. So this is what I want you guys to learn. That the whole of these ones are our dendrites. Now, the moment they come together in any way, let's rub this one off. The moment they come together like that, they can be three, but provided they come together. What they form okay, they form something. So this something so I'm saying they can form something. So this something they are forming can enter the cell body. Are you following? It can enter the cell body. And then the cell body can also push. You get? So if those ones are dendrites, this thing that they form, this one, is what they call the dendron. And the role of the dendron is to take everything it's having to the cell body. Now, whatever the cell body delivers, the cell body delivers it via the what? The axon. So that's how you can understand dendrites, dendron, and then axon. If you have that thing, everything you read about the dendron, you will never forget, because you will know that the dendron is moving towards the what? The cell body. Even when you read about dendrites, you never forget, because you know that dendrites, because of this character R receiving. I told you that. And you know the axon, you know what it does. You know, this is the axon and this is the cell body, so it's like away from the cell body. If you know this cascade, then whatever you read about them, you never forget. It won't be confusing. I told you about the synaptic knobs, and you know where they are. I read it for them, they're about entering here. Yes. I read that everywhere you see the synapse, expect synaptic knobs. Synaptic knobs simply means knobs at the synapse. They look like knobs. Don't you know knobs? Like that with a dot at the end. That's what they call a knob in English, without even the word synaptic. See? That's what they call knobs. So when they are present at the synapse, that's when we call them synaptic what? Synaptic knobs. Hope you are together there. But I don't know if you know what they really do. But I told you we shall see them when we reach synaptic. Okay, when you reach the synapse, because the synapse is a topic on its own. And it's also very important. Then the other thing you really need to understand concerning the synapse, is this. Yeah. That if at all, okay, we have, okay. Let me teach people this also, because most of you are not aware. We have what we call sensory fibers and motor fibers, not so? And they are in the peripheral nervous system. We have what we call the sensory neuron, not so? And then it comes and it enters the CNS. So I'm going to put here CNS, and then it leaves. So this one is what they call the motor neuron. I want to show you other synapses. So to make matters worse, even in the CNS, we have there some fibers. We have the fiber that is going to connect these two. Yes. Sorry, yes, we have a fiber that is going to connect those two, what we call a neuron. But for it is inside the CNS. Yeah, CNS. So here where they are connecting, so those are the points of connections. Like here they are connecting and here they are connecting. First and foremost, since this neuron is between the sensory and the motor neuron, we shall call it the intermediate neuron. If we don't call it the intermediate neuron, we shall call it the relay neuron. And you should be knowing all those terms, because depending on who is setting, they can use the word they want. Someone may say, may don't even want to use that. Someone says, let me use interneuron neuron. Someone can say interneuron. Yeah, at medical school, they will use interneuron. I don't know if any of your books has interneuron, but they can just say interneuron, relay neuron, intermediate neuron. Should be just okay with that. So, what is the other thing I want you to know? That how do they connect? They connect like that. Are you seeing what is happening? Like that, eh? This one is fork-like, even this one is fork-like. And then there they are meeting. So those meeting points you're seeing, the ones I've edited, they are what they call synapses. So this one is a synapse. So when they wake up one day and tell you, or you read it and note in the textbook that says the sensory neuron synapses with the relay neuron, don't be confused. Even this one is a synapse. Yeah. So when they tell you that the interneurons or a synapse with the motor neurons, you also shouldn't get what? Confused. So the other thing that you really need to understand about these synapses is that they're also about transmission. Eh? They're just for transmission of nerve impulse. Yeah, because it may not be easy for it to just move, yeah, from the sensory neuron to the relay neuron just like that. We may need the synapse to mediate this. You understand? Yeah, yeah, that's why they come in. Like from the sensory neuron, it may not just that one may not be possible, but we may need a synapse that is really going to help us with the transmission of the nerve impulse from the sensory neuron to the relay neuron. Just read textbooks. This information, the basic information you've gotten today, can help you read textbooks and you get the content. So that's what I can say about the synapse. You've also realized where else they are. Okay, when they are enter CNS, entering effector synapse, then also other synapses are here. Get it? I think, what else do we have on the structure that we've not talked about? Let me see. Schwann cell, we talked about the Schwann cell. Myelin sheath, we talked about it. Node of Ranvier. Maybe we should also talk about it. Node of Ranvier. I think it's going to be our last thing. Unless otherwise, maybe the rest of the things we shall find them in the notes. Okay, now we shall reach nerve transmission, but I want to talk about something here. Okay. I want to draw 3 of them. I'm going to draw 4 of them. This is 1. This is 2. This is 3. This is 4. 1, 2, 3, 4. You get? And then you people know this is going to be the direction of impulsing. There is something that you will understand later, but here I'm going to just make it a bit brief. Yeah? Just make it a bit brief. So these ones are the nodes of Ranvier. Node of Ranvier. Even the rest are nodes of Ranvier. So let's assume this is the direction of nerve impulse. Now, how is this one going to move? Remember, this thing is what they call the myelin sheath. What you need to know about the myelin sheath, that the myelin sheath insulates. Yeah. I don't know, but this is something you will actually understand when we talk about conduction, because now here it may not make sense. Here it may not make sense, because if I tell people, because those of you who have studied this, you know that when the nerve impulse starts to move, it moves like a wave of depolarization. I think you will only understand it when we talk about the properties first, then yeah. Because what I want to talk about is this, like you all need to know that an impulse moves like a wave of depolarization. This is what you need to understand. But now we are bringing in a word depolarization. And when I talk about depolarization, there are things we are going to find in lesson 2. And when I talk about the wave of depolarization, that means we need to talk about the balance. We need to talk about the balance between sodium ions and then potassium ions. Things we've not yet talked about. That's why I need to first teach you resting potential, then action potential. What I'm trying to talk about is the role of the node of what? Of Ranvier. Remember, the first learning outcome is you people being in position to relate the parts to their function. But for you to understand the role of the node of Ranvier, I can give it to you and you cram. It is strictly for saltatory conduction. That is the role. But you cannot just cram saltatory conduction. You need to know why is it actually called saltatory. What do we have those jumpings? So what I'm saying, it's a wave of what? Depolarization. Are you following? And after that, what am I saying? Depolarization is all about a balance between sodium ions and potassium ions. Things we are supposed to study later. Yeah, right now, don't be confused. Yeah. But please, when you go, the very first research I'm giving you is you guys being in position to make research about the sodium potassium pump. If you don't know the sodium potassium pump, you won't understand. That's why I told you that certain things they removed are actually important. I don't see cell physiology so much in your book, but now we need to know the sodium potassium pump for you to be in position to understand how the impulse shall move as a wave of depolarization. So that when I talk about evoking or firing action potentials, you understand those things. Because if you don't know how equilibrium is maintained between those two ions, or between the concentration of those ions, then it may be kind of absurd. So, because of these ions, remember they are supposed to diffuse. Remember they are diffusing across the membrane. Across the membrane of the cell. Which cell do we have here? It's the nerve cell. So, where the myelin sheath is insulating, we cannot have diffusion. The people getting the impulse to move, it moves like a wave of depolarization. And depolarization means that we are actually evoking, or it is related to action potential. You understand? Yeah. The moment depolarization starts, finally we shall evoke the action potential. And it's because of a balance between these sodium ions, you get, and the potassium what? Ions. And since we are dealing with a cell, which cell in place? It's a nerve cell. I'm now teaching you work ahead. So it is okay for it not to make sense. Nerve cell. So a cell has a membrane, you all know that. So, and we expect to have diffusion of the ions we are talking of. Are you listening? But again, we are saying the same cell is surrounded by what we call the myelin sheath, which insulates. And when it insulates, we don't expect any diffusion to take place. That means diffusion is only going to be possible wherever I'm going to tick here, only in those gaps of the nodes. Okay, at only the nodes of Ranvier. That's where diffusion is going to be possible. That means here we shall not have the transmission. Transmission will not be happening. So what will result? Do you know how the nerve impulse will move? Remember here it will be possible. Remember here now another myelin sheath is coming. Do you know how the impulse will be moving? The impulse will be moving. Remember, this is where the diffusion is possible. So that's where the depolarization is possible. So that's where the impulse can move. So it will be jumping. It will jump from here to here. Then again, it will jump from here to here. Then it will jump from here to here. Then it jumps there. That's how the impulse will be moving. Yeah? It will be jumping. It will be jumping like that. It will jump from here to here. Again, it will jump from here to here. It will jump from here to here. It will jump from here to there like that. Like that. Someone may be like, now, why is it jumping? Here we don't have, okay, here we have myelin sheath, which insulates. And when it insulates, we cannot have diffusion. Diffusion of what? Sodium and potassium ions. That means we shall not have a wave of depolarization moving. That means the impulse will not move in those regions. But here, where we have the node of Ranvier, there is no myelin sheath, so there is no insulation, so diffusion will only be possible there. So depolarization will only be possible there. So transmission of the nerve impulse will only be possible there. So it will just keep on jumping node to node. Why node to node? It is at the node where we have no insulation because we have no myelin sheath, so diffusion will be possible. So deposition will be possible, action potentials will be evoked, everything will be happening, and the nerve impulse will be transmitted. Things like that. But you will understand this more in lesson 2, where we shall talk about resting potential, we shall talk about those ions, the sodium-potassium pump, how they diffuse and everything. But this is just like now the details of the next step. But I just wanted you to understand the jumping, the jumping, yeah, the jumping part. So that jumping part is what they call salutatory conduction. Yeah. So that jumping thing, that jumping, when you read FA, there is a way FA brought it out. It communicated why they are called salutatory. Yeah. So that jumping conduction, sorry, conduction, it's what they call salutatory. That jumping, you've realized. Yeah. And trust me, salutatory conduction is among the things we shall come across next. Our next talk shall strictly be about that conduction part. Yeah. Yeah. And I think FA, so you go to FA. I want someone to go to FA after here. You get us that statement they gave. Why it's called salutatory. Yeah. They talked of a certain word that relates to salutatory. I want you guys to go and find it out on your own. But salutatory is in line with jumping. Yeah. I've already told you about everything. You know, one of the roles of membranes is transport, like in and out, things like that. Materials can be molecules, ions, anything. So I think now we can watch the video of the sensory and motor neurons. We come and read notes, and then we leave this place. Yeah. Because the weak ones have already left us here. We don't want to overstudy. The sensory and the motor neurons, 3D animation. How does the structure of neurons enable your reflexes? Structure and function, types of neurons. Neurons don't have cells. How neurons communicate? Types of neurons. Sensory, motor. I think this one will work. Okay, let's see this and see.
Let's dive into the fascinating world of neurons, the building blocks of our nervous system. But wait, did you know that neurons come in different types? Let's explore the diversity together. But first, hit that subscribe button and ring the notification bell so you never miss our exciting science content. Now, let's jump in. Before we dive into the types, let's quickly recap what neurons are. Neurons are specialized cells that transmit information throughout our nervous system. They're like the messengers of our body, helping us move, think, and feel. But did you ever wonder if all neurons are the same? Spoiler alert, they're not. Let's uncover the different types. First of all, let's discuss sensory neurons. These neurons are like the body's sensors. They pick up information from our environment, like touch, taste, and smell. Can you think of an example of a sensory experience? Drop it in the comments below. Now, let's talk about motor neurons. They're the ones responsible for carrying signals from the brain and spinal cord to muscles and glands, enabling movement. The last ones are interneurons. Interneurons act as intermediaries, processing information and transmitting signals between sensory and motor neurons. They play a crucial role in decision-making. Okay, here's where you become part of the conversation. In the comments, let me know which type of neuron you find most intriguing and why. Are you more fascinated by sensory neurons, motor neurons, or the mysterious interneurons? I'll be responding to your comments throughout the week. Thanks for joining me on this neuron adventure. If you enjoyed learning about the different types of neurons, then you will love the video on the left, which is the detailed neuron you find most intriguing.
Okay, I think that video tried to bring everything out. So the assignment I can give at this point is maybe you go and watch more. Yeah, go and watch more videos. Okay, now concerning the histology, you're going to go and read these things on your own. Or maybe I'm going to go through them very fast. You first take screenshots. Then I go through them very fast. Yeah. You first take that screenshot. You take these screenshots that are clean, yeah? You take that one. After that, you take that one. You take that one. After you take that, so don't say I never gave you my organized or summarized notes. Then after you take this table, very important, part of the neuron and the function. After you give your friends the screenshots in the group, yeah, then, yeah, this note, I think it is the last one. Because I think the next thing is another chapter. You see, here the next thing is another chapter. See, cell division, which we completed. So that's where it will end. Yeah? So I'm going to go through them chap. Yeah. You see, so nervous tissue, neurons. You all know it's having neurons also, and it's having the Schwann cells, even the receptor cells that I told you about receptor cells. Yeah. The neurons are the functional units, you know, basic structure. You know, they have the receptors, you know what they do. You know, the effectors, the ones that are either muscles or glands, and they're the ones that react or respond, isn't it? And then the receptors are the recipients, the ones that receive. So I'm just putting out the keywords, eh? Yeah. So there are three types, the sensory ones or afferent. So this is something new. Yeah. But for me, I just used to get them in alphabetical order, like A comes first, then E next. Just like the sensory ones come first, then the motor. Afferent. Yeah, efferent motor, then afferent sensory. Yeah, sensory first, then motor. Then about A and E, A comes first, then E next in the alphabetical order. So it's like that. You get? What do these ones do? They conduct impulses, even these ones conduct impulses. It is special that the sensory ones, they move from receptors to the CNS, that is brain and spinal cord. But the motor ones, it is away from CNS, don't you know? And of course to the effectors. The inter ones, what do? They contain sensory to motor. We said that. The structure of sensory, motor, and relay neuron, how do they look like? So the sensory one is here. So the direction is like this. So don't be confused. So the sense organ is here. You can see the dendrites that you see. You can see the nucleus, myelin sheath, and the neurolemma making up the Schwann cell. You can see the dendron here before the cell body. It is a dendron, and after the cell body, it is the axon. The cell body has the nucleus and the Nizos granules. You can see that space called the node of Ranvier. You can see lastly this side of the CNS. As it is entering the CNS, it must synapse. So we get the synaptic nodes, and of course they are just there to pass on the stimulus, because I told you they are key in nervous transmission. So that is the sensory neuron for you. Of course, this is the sense organ, not the receptor organ. You know that. Then the motor neuron. So the motor neuron, it will now be in this direction. They just wanted to maintain the CNS on one side. Yeah. So I think you can see also that the dendrites, these ones, they're just next to the cell body, as I said. So the cell body is just releasing one thing, the axon. So if you really want to see maybe the dendron, maybe you can just microscopically look for two dendrites that are joining. I told you all that. I don't want to repeat myself. Dendrites, they receive nucleus, myelin sheath, neurolemma, they get that. Node of Ranvier. So this side we have the synaptic knobs that pass on everything to the effector organs, and that is the motor neuron for you. The carrilane neuron, it is the cheapest thing in this topic. Just look at how it looks like. It's having its dendrites receiving, then the dendron after joining together, then it delivers to the cell body, which cell body has a nucleus, and the cell body delivers everything via the axon because of the direction. And lastly, we have the knobs. And also the knobs are just there to pass on the stimulus, but remember they are passing it on as nerve what? Impulses. Don't think it's still the same stimulus as the one we got from the receptor organ. Remember, it is transitive state. Yeah, so they say stimulus, but it is in terms of impulses. You get that? Then the functions, you all know. So they are beginning. This side we are going to have the part, then this side the function. So cell body, it has the nucleus that controls. Nizos granules, we agreed ribosomes, RAFI-R, protein synthesis, Golgi body for modification. Dendron, we agreed it is towards the cell body. Dendron towards cell body. Axon, it is away from cell body. The dendrites, they just receive. Synaptic knob, we agreed. They are all to do with the synapse. And I told you what a synapse is. Synapse, we can only see it with a microscope. And it is between two nerve cells, we saw that. And I told you we shall understand it most when we reach neurotransmission. That's why they are talking of neurotransmitter substance. But the synapse is its own topic. So as of now, just understand one thing, where it is. And you have those illustrations in the workbook where the synapse is. You just understand that. About its structure, it's what will help you understand such things. But you all know we have a synapse as we enter the effector. So the statement will actually make sense. But it will make deeper sense when we reach lesson 2. So the synaptic knob, at least leave knowing that this knob you're seeing, it's what will release the neurotransmitter substance. And we shall see the different ones. The acetylcholine SCH, the noradrenaline, or the norepinephrine. You get? Schwann cell, we agreed it's the one that produces the myelin sheath. The myelin sheath, it's there to surround and insulate our axon. Don't you know that? The node of Ranvier, we talked of the saltatory, not salu, but saltatory conduction. And I try to tell you about that. And the mere fact that we are jumping, even the word jumped is here, we are increasing speed. Like every time you jump, even if you're moving and you decide to move as you're jumping, you increase speed. So the neurolemma, we said that lemma means membrane, and you know all that membranes are the ones that allow diffusion of whichever ions that are supposed to participate. But depolarization, I told you it's a technical term. It will be in lesson 2. Hope we are together. Yeah. These are just notes. The ones I usually call extraordinary content, a collection from textbooks. They are saying, provided it's nerve fibers in a connective tissue sheath, we call it epinurium. Of course, the moment you see something like new, it is for neuron, new. So these are just facts. They're just facts because of epi. Epi in biology goes with covering, sheath. Sheath with epi. Don't surprise a good biology student to be in the same statement. You see? Sensory or afferent, they convey to the CNS. Motor or efferent, away from the CNS. Don't you know that? But there are those we call mixed nerves. And mixed nerves are the spinal nerves. You will see that, especially at medical school. But you just understand that mixed nerves are spinal nerves. Like for them, they convey in both directions. They're not like sensory that are specific toward the CNS and motor that are specific away from the CNS. These ones, the mixed ones, are in both directions and they are the spinal nerves. Spinal nerves simply means nerves that radiate from the what? From the spinal cord. So, you people, I believe I have over-talked and I'm tired. So this one, it has actually been successfully covered. So expect me to come back here, part B, as we talk about transmission. Yeah. But the properties of nerve fibers, they will be our what? Our next stop, where we shall find things of conduction and everything, resting potential. So the real biology is actually next, where we shall talk about the resting potential, where we shall talk about the action potential, and we shall enjoy even seeding to creation and maintenance of resting potential, action potential. We talk about things like depolarization, hyperpolarization, refractory period, and then the science will make sense. You see? Repolarization, hyperpolarization, depolarization, refractory period, and everything will just be wow. And when we are done with such terms, we shall also talk about those things. The conduction that I told you, it's also part of our next stop. Yeah, you see, wave of depolarization. And they are telling you that's how a nerve impulse moves. And it is something we mentioned. That's why I told you, like, it's like I gave you an overview of what you're going to see next. You see? Are you seeing the jumping I was telling you about? Do you see the jumping? This is the node of Ranvier. So that jumping is what they call the saltatory. Saltatory. In FA, they will tell you why they took that. It's even here. Saltatory. But this will be next in the future. I don't know. Here we shall talk about the threshold, the all or nothing law, the factors influencing the conduction speed. I think also here in the syllabus here, Roman 2, factors that are affecting impulse transmission speed. Yeah. The things of inhibitor and excitatory synapse, those ones are easy. I think after factors, then the synapse will begin. Yeah. So that's why I told you that in case anything about the synapse has not been very clear, you leave it. The synapse is its own subtopic or its own concept in the whole topic, so you will wait for it in the future. So I think I've given you the plan of everything. Yes, conceptor.
Excuse me, Doctor, was inquiring of something. These positions of the cell bodies, they have different positions for different neurons, the sensory neuron, the interneuron, and then the motor neuron. Do they have a particular significance for each?
Yes, and it was talked about, but we shall see that more when we reach the synapse. Have you heard?
I've not got it well.
I've told you that they do, and we talked about it in terms of the synapse, but we shall see that when you reach the synapse, because you very well know that every time you're entering the CNS, you have a synapse. Every time you're entering the effector organ, you're having a synapse. Every time the sensory neuron meets the relay, you have the synapse. And of course, what synapses are the synaptic knobs. Where do they come from? The axon. The axon is delivered by the cell body. The cell body comes from the dendron. The dendron comes from dendrites.
Okay,
Have you heard? So you wait for the roll at the right time, because now you have the structure. Yes, cool. What are you asking?
Good afternoon, Doctor.
Mm.
Doctor, for me, it is not about work. But, Doctor, I have a question for you.
You ask. Now you want me to tell you that now you ask.
Doctor, which combination did you offer?
Which year?
I don't know, because I see, like in
Okay,
physics.
maybe I'm going to respond to that maybe in the discussion group, because I told you these are worldwide classes, so we upload them somewhere. Maybe I'll respond to that in the discussion group. But I did different combinations in different years, because you can repeat senior 6. Education has no limits. You can do senior 6 as many times as you can. It's just a matter of registering, and then you sit for papers. Exactly. So it's like finding a doctor who is handling cancer patients and also children. So you ask them, when did you really do pediatrics and then oncology? But it is very possible. Haven't you found engineers who do computer science, but the engineering is mechanical? So education has no limits. You can do whatever you want. Yeah, you can do whatever you want. I also have a short course. When you do medicine, you can do a short course in education. It's called a postgraduate diploma. Postgraduate, meaning that postgraduate after graduating. PGD in education, it's just 9 months. Yeah. But if at all you begin with education again, you're supposed to study for 3 years, then medicine 5 years to 6. But if you begin with these 6 years, then you can come for these 9 months later. But the good thing with this course of education, when you do education, you can do any other course after that. Yeah. Because they believe you've learned a lot of things. Because they study a lot of irrelevant work. That is it. So I think I don't have any other questions. I don't know if people have noticed, but a lot of content has been said. A lot of content has been said. A lot of content has been said. Please, you go back and read. Hey, coordination. You're going to get confused in lesson 2. Otherwise, see people bye. Whoever has questions, we meet in the discussion group. Bye-bye.